Hello there, and welcome to Science for Sleep, where curiosity slows down for the evening. The universe feels a little softer around the edges, and enormous cosmic mysteries somehow become strangely comforting. Tonight, we are drifting towards something truly difficult to imagine. Not a black hole, not a supernova, not even a distant planet, but a galaxy so large that it stretches the limits of what spiral galaxies are supposed to be. Its name is NGC 6872, and somewhere far beyond the familiar glow of the Milky Way, this colossal structure quietly turns through space like a giant wheel, made of stars, gas, dust, and time itself. It is so enormous that if you placed our own galaxy beside it, the Milky Way would begin to look a little modest by comparison. Which, considering our galaxy contains hundreds of billions of stars and a supermassive black hole, is already saying quite a lot. Now, galaxies are usually described with tidy little words like spiral, elliptical, dwarf, barred, irregular. Astronomers do enjoy categorizing things. It helps keep the universe from feeling completely unmanageable. But every so often, nature builds something that feels slightly excessive, something so stretched out and massive that it almost looks unfinished, as though the cosmos accidentally pulled one of its galaxies too far while rearranging furniture. That is part of what makes NGC 6872 so fascinating. It does not merely exist, it sprawls. Its spiral arms reach outward across space in long, sweeping arcs that seem less like galactic structures and more like entire star systems trying to escape in slow motion. Even by cosmic standards, it is unusually large, unusually extended, and unusually calm-looking for something shaped by gravitational chaos. And tonight, very gently, we're going to spend some time there. Before we begin wandering through this enormous galaxy together, though, I'd love to ask you something simple. Where in the world are you listening from tonight? Is it late evening where you are? Early morning? Maybe you're already tucked into bed with the lights low and your thoughts beginning to slow down a little. Or perhaps you're listening during a quiet train ride, or while rain taps softly against a window somewhere far away from everyone else. Funny, isn't it? A conversation about galaxies happening between people scattered all across one small planet, each of us living beneath the same sky, while hardly ever stopping to think about just how tiny that sky really is compared to what waits beyond it. And if you find this journey relaxing, interesting, or simply a peaceful way to end the day, I'd be very grateful if you liked the video and subscribed. It helps this calm little corner of science continue drifting outward toward other curious night owls, sleepy travellers, and people whose brains refuse to stop asking impossible questions at midnight. Now then, let's settle in for a while, because somewhere roughly 212 million light-years away from Earth, inside the constellation known as Pavo, there spins a galaxy so immense that even astronomers occasionally stare at it and quietly reconsider their sense of scale. The first strange thing about NGC 6872 is that most people have never heard of it. That might sound surprising. After all, this is one of the largest known spiral galaxies in the observable universe. You would think something carrying that title would receive the same sort of celebrity attention as famous objects like the Andromeda Galaxy or the Whirlpool Galaxy. But astronomy is a bit like geography. Some places become household names while others remain quietly extraordinary in the background. NGC 6872 belongs firmly to that second category. It does not sit close to us like Andromeda does. It is not especially bright from Earth. You cannot step outside with binoculars and casually point toward it, while pretending to understand celestial coordinates. In fact, even professional telescopes struggled for a long time to fully appreciate just how enormous this galaxy really was. Part of the problem comes from distance itself. When astronomers observe extremely remote galaxies, they are not seeing them as they exist now, they are seeing ancient light. The light leaving NGC 6872 tonight will not reach Earth for another 212 million years, which means that somewhere on Earth Dinosaurs had only recently disappeared when the photons currently entering our telescopes first began their journey. That thought alone has a way of slowing the mind down a little. Every image of a distant galaxy is also a time machine, not metaphorically, literally. The universe has no faster method of communication than light itself, so when astronomers observe something far away, they are observing history still travelling toward us through space. An NGC 6872 has had quite a long time to become what it is. At first glance, it resembles what you might expect from a classic spiral galaxy. There is a bright central region surrounded by broad rotating arms filled with stars, but then your eyes begin following those arms farther outward, and somehow farther still. The galaxy spans well over 500,000 light-years from end to end. For comparison, the Milky Way is roughly 100,000 light-years across, depending on how you define its faint outer boundaries. That means NGC 6872 stretches to around 5 times the diameter of our own galaxy. Trying to picture this is difficult because human brains are not particularly designed for cosmic scale. We struggle enough with parking lots and grocery store layouts. A structure 500,000 light-years wide is not something evolution prepared us to emotionally process. So instead, the brain starts reaching for comparisons. Imagine shrinking the Milky Way down to the size of a dinner plate. NGC 6872 would become something closer to a dining table. Same basic structure, same general idea, but operating on a scale that feels almost unnecessary. And yet, despite its immense size, the galaxy is not chaotic in the way people often imagine giant cosmic objects to be. There are no visible explosions swallowing entire star systems every second. No glowing science fiction storms tearing reality apart. In truth, galaxies move with astonishing patience. Everything in NGC 6872 is happening slowly. Stars orbit gradually through the galaxy over hundreds of millions of years. Gas clouds drift and collapse. Gravity gently reshapes entire regions across timescales longer than complex life has existed on Earth. Even the dramatic interactions responsible for the galaxy's unusual appearance unfold at speeds that would feel almost motionless to human observers. This is one of the strangest features of astronomy. The largest events are often the slowest. A single orbit around the centre of a galaxy can take hundreds of millions of years. Entire spiral arms evolve over spans of time so long that human civilization would vanish before noticing even a slight change. Galaxies are not frozen objects, but they might as well appear frozen to creatures with lifespans measured in decades. And still, despite that calm appearance, something unusual happened to NGC 6872. Actually, something collided with it. Not head-on in the dramatic style movies tend to prefer. Galactic collisions are usually less like car crashes and more like ghostly dances between enormous gravitational systems. Stars rarely strike each other directly because the distances between them are so vast. Instead, gravity stretches galaxies, twists them, and slowly rearranges them over immense spans of time. NGC 6872 is currently interacting with a smaller companion galaxy called IC 4970. Now, smaller in astronomy can be a little misleading. IC 4970 is still a galaxy containing enormous numbers of stars, but beside NGC 6872, it looks somewhat like a canoe tied beside a cruise ship. The gravitational interaction between these two systems has likely helped stretch NGC 6872 into its current elongated form, pulling its spiral arms outward into those remarkable extensions astronomers study today. In other words, the largest spiral galaxy did not become enormous entirely on its own. Gravity shaped it, which honestly feels fitting. Gravity is patient enough to sculpt entire galaxies over billions of years without ever needing to hurry. It simply keeps pulling, quietly, relentlessly. continuously reshaping the architecture of the universe one orbit at a time. And gravity, as it turns out, has an extraordinary talent for making things complicated. When most people imagine galaxies, they picture neat spirals rotating peacefully in isolation. But real galaxies are social creatures in a cosmic sense. They interact constantly. They drift through galaxy groups and clusters. They pull on one another. They exchange gas. Sometimes they merge completely, forming entirely new structures from the remains of older ones. Our own Milky Way is doing this right now. Several billion years from now, the Milky Way and the Andromeda Galaxy are expected to collide and merge into a much larger galaxy. Thankfully, by cosmic standards, that remains comfortably far in the future. You still have time to finish your tea. But NGC 6872 gives astronomers an opportunity to observe something similar already in progress. Its enormous spiral arms appear stretched and disturbed partly because another galaxy passed close enough to tug at them gravitationally. The interaction triggered waves of star formation throughout the galaxy, especially within the extended arms where gas clouds became compressed enough to begin creating new stars. That means some parts of NGC 6872 are filled with relatively young stars born from gravitational disruption itself. There is something oddly comforting about that idea. Even on galactic scales, disturbance creates change. Motion creates structure. Collisions create new beginnings. Of course, astronomy tends to describe these events very calmly despite their absurd scale. You will often hear phrases like gravitational interaction or tidal distortion, which sound almost polite. But what they really describe is one galaxy gradually pulling another apart over hundreds of millions of years. Scientists are masters of understatement sometimes. Still, even with all this stretching and interaction, NGC 6872 remains recognizably spiral. Its central structure survived. Its arms still curve outward gracefully. And that raises an interesting question. Why do spiral galaxies exist at all? You might think stars orbiting a galactic center would eventually smear themselves into featureless disks over time, like cream stirred into coffee. Yet spiral patterns remain surprisingly stable across billions of years. Astronomers still debate some details of how these structures persist, but the general picture involves density waves moving through galactic disks. The spiral arms are not rigid structures made from the same stars forever. Instead, they behave more like traffic jams. Oddly enough, traffic turns out to be one of the better analogies here. Cars move through a traffic jam while the jam itself remains in roughly the same place. Similarly, stars move through spiral arms while the arm structure persists as a region of higher density. Gas clouds entering those regions become compressed, triggering star formation. Young hot stars light up the arms brightly, making spirals visible across enormous distances. So when we look at NGC 6872, we are not merely observing static architecture. We are seeing motion frozen by scale itself. Entire generations of stars have already formed and died within that galaxy, while multicellular life on Earth was still evolving in ancient oceans. And perhaps that is part of why giant galaxies feel strangely calming to think about late at night. They operate outside ordinary human urgency. Nothing in NGC 6872 cares about deadlines, emails, delayed flights, forgotten passwords, awkward meetings, or whether you replied too slowly to a text message 3 days ago. Galaxies simply continue evolving at their own pace, carrying stars through darkness with immense patience. That does not make human problems meaningless exactly. If anything, it makes them feel temporary, manageable, small enough to breathe around again. Astronomy has a peculiar way of doing that. The more enormous the universe becomes, the quieter everyday anxieties sometimes feel. And NGC 6872 is particularly good at creating that effect because it pushes scale almost beyond comprehension. A 500,000 light-year wide spiral galaxy already sounds exaggerated before you remember that it's only one galaxy among hundreds of billions in the observable universe. Hundreds of billions. Even saying the number aloud does not help much. If every galaxy were a grain of sand, there would still be enough grains to fill entire coastlines. Somewhere among that incomprehensible population drifts this quiet giant, slowly turning through the darkness while light from its stars crosses unimaginable distances toward observers who evolved on a small rocky planet orbiting an ordinary yellow star. And the deeper astronomers studied NGC 6872, the stranger and more fascinating it became. Because once you start examining galaxies this large, closely you begin discovering that size alone changes everything. The structure behaves differently. The star formation patterns shift. The gravitational interactions become more dramatic. Even the way such galaxies evolve over time begins separating them from more familiar spirals like our own. Trying to understand the true size of NGC 6872 is a bit like trying to understand the size of an ocean while standing inside a bathtub. The numbers sound impressive at first, certainly, but the human brain has an unfortunate habit of flattening enormous scales into neat little facts that no longer feel emotionally real after a few seconds. 500,000 light-years across. That is the figure most often associated with NGC 6872. Roughly 522,000 light-years from one end of its stretched spiral arms to the other. Astronomers debate exact measurements depending on which faint outer regions are included, but however you calculate it, the galaxy is absolutely gigantic. And the strange part is that even saying gigantic barely helps, because galaxies are already enormous beyond normal comprehension. Our own Milky Way contains somewhere between 100 and 400 billion stars depending on how generously you count dimmer populations hidden in its outskirts. It spans around 100,000 light-years. That alone is difficult enough to visualize. Most people, understandably, never sit quietly at lunch wondering how large 100,000 light-years actually is. But then NGC 6872 arrives and calmly stretches itself to 5 times that diameter like the universe trying to show off a little. To make matters even stranger, this is not some shapeless cloud of stars barely holding together. It is still recognizably a spiral galaxy. It still has sweeping arms, rotating structure, active star formation, and a bright central region. It did not simply puff outward randomly into a diffuse blur. Somehow, gravity managed to maintain a coherent spiral structure across distances so large that light itself needs over 500,000 years to cross from one side to the other. That means if a civilization existed near one edge of the galaxy, and somehow sent a light signal toward the opposite side, the message would still be travelling when entire species on Earth had already evolved and vanished. You could invent agriculture, build civilizations, lose civilizations, rediscover mathematics, invent the internet, argue online about whether pineapple belongs on pizza, disappear as a species entirely, and the light would still not have arrived. Galaxies have a way of humbling timelines, and yet, from a distance, NGC 6872 appears oddly graceful, not frantic, not violent, just stretched, elongated, calm in the way only gigantic cosmic structures can appear calm while secretly operating under forces beyond ordinary imagination. Astronomers first identified the galaxy back in 1835 when the English astronomer John Herschel catalogued it during observations of the southern skies. At the time, nobody fully understood what galaxies even were. In fact, for a surprisingly long period in scientific history, people debated whether spiral nebulae were objects inside the Milky Way or entirely separate island universes. The second option turned out to be correct, though island universe still sounds wonderfully dramatic. Imagine discovering that the faint smudge visible through your telescope is not a nearby cloud of gas, but an entire galaxy containing billions upon billions of stars. Astronomy in the early 20th century must have felt a bit like repeatedly opening doors only to find larger rooms behind them forever. First, the solar system seemed enormous. Then, the the Milky Way dwarfed it. Then other galaxies dwarfed the Milky Way. Then galaxy clusters dwarfed individual galaxies. Then superclusters dwarfed clusters. Then scientists discovered the cosmic web itself, vast filaments of galaxies stretching across unimaginable distances like glowing threads through darkness. Every time humanity thinks it has reached a comfortable sense of scale, the universe quietly unfolds another layer. NGC 6872 belongs to that tradition rather well. Even among spiral galaxies, it occupies a category that feels slightly unreasonable. Most large spirals settle into a more manageable range. The Milky Way, Andromeda, the Triangulum Galaxy, all impressive, all vast, but still operating within scales astronomers generally expect from mature spiral systems. NGC 6872, meanwhile, looks as though somebody took a normal galaxy and carefully stretched it outward like warm dough. Its arms are the key to this impression. Spiral arms in galaxies are not unusual, but the arms of NGC 6872 extend astonishing distances from the central core. They sweep outward in thin, elongated structures filled with gas, dust, and clusters of newly formed stars. Some regions appear almost fragile despite spanning distances larger than entire galaxies. And this creates an interesting problem. How do you maintain a structure that large without it simply falling apart? Gravity, of course, is the answer, though gravity rarely gives straightforward answers. The galaxy's enormous mass helps keep it together, including not only visible matter but also dark matter, the mysterious invisible substance thought to make up most of the universe's mass budget. Without dark matter, galaxies would not behave the way they do. Actually, without dark matter, many galaxies might not exist in their current forms at all. Astronomers discovered this problem during studies of galactic rotation. According to normal physics, stars farther from a galactic center should orbit more slowly, much like outer planets in the solar system move more slowly around the sun. But galaxies refuse to cooperate politely with those expectations. Stars at the outer edges move too fast. Much too fast. Fast enough that galaxies should theoretically fling themselves apart unless additional invisible mass existed to hold them together gravitationally. And so scientists proposed dark matter, a substance we still cannot directly observe but whose gravitational influence appears everywhere across the cosmos. Which means that NGC 6872 is likely embedded inside an enormous dark matter halo stretching far beyond its visible structure. The galaxy we see, the glowing stars and gas, represents only part of the system. Hidden around it is an invisible gravitational framework large enough to stabilize those extraordinary spiral arms. There is something wonderfully strange about that. One of the largest spiral galaxies in the known universe may owe much of its existence to matter nobody has ever directly seen. The universe does enjoy mysteries layered inside other mysteries. Of course, size alone is not what makes NGC 6872 unusual. Plenty of giant elliptical galaxies exceed it in total mass. Some galaxies contain trillions of stars. But giant ellipticals are different creatures entirely. They often form through repeated mergers that scramble their structure into enormous rounded systems with little remaining spiral organization. Spiral galaxies are generally more delicate. Maintaining those elegant rotating arms becomes harder as systems grow larger and experience gravitational interactions. Over enough time, collisions and mergers tend to disrupt spiral patterns. That is why galaxies like NGC 6872 attract so much attention. It somehow managed to become extremely large while retaining recognizable spiral architecture. Though admittedly, retaining may be a generous term. The galaxy clearly shows signs of distortion. Its interaction with the smaller galaxy IC 4970 has stretched and reshaped its arms dramatically. One side appears more elongated than the other. Tidal forces ripple through the structure like slow-motion waves, and yet the overall spiral form survives. Barely perhaps, but beautifully. Galactic interactions themselves are deeply strange to think about because they happen so slowly that no human being could ever directly witness one unfold. Even entire civilizations barely occupy a fraction of a galactic heartbeat. If you could somehow speed up time and watch galaxies interact over billions of years, the universe would look astonishingly dynamic. Spirals would twist together, tidal tails would extend outward, entire systems would merge and reform, star formation would flare brightly in compressed clouds of gas. Black holes would drift toward each other at galactic centers before eventually colliding. But from our perspective, galaxies appear frozen because we live far too briefly. It is a little like staring at the hour hand of a clock and insisting nothing is moving. Everything in astronomy depends on patience, and NGC 6872 especially rewards patient observation, because its immense size allows astronomers to study how gravitational interactions reshape giant spiral systems over time. Those stretched arms are not merely decorative structures, they contain clues about the galaxy's past encounters, internal dynamics, and future evolution. Some regions inside the arms contain clusters of very young stars only a few million years old, practically newborns by cosmic standards. These stars likely formed because tidal interactions compressed gas clouds enough to trigger star formation, which means that somewhere out there, entire stellar nurseries exist because one galaxy drifted too close to another hundreds of millions of years ago. Gravity again. Always gravity. It pulls galaxies together, reshapes them, triggers star formation, feeds black holes, bends light itself, and quietly controls the large-scale structure of the universe while remaining completely invisible. Not bad for something you cannot switch off. Interestingly, the farther astronomers looked into the outer regions of NGC 6872, the more surprising the galaxy became. Faint streams of stars extend outward almost impossibly far from the centre. Gas clouds spread through the elongated arms in delicate structures that seem fragile compared to the galaxy's enormous scale. And this raises another strange point about galaxies. They are mostly empty. Science fiction often portrays space as crowded with hazards, asteroid fields, explosions, spacecraft dodging debris every few seconds. Real galaxies are astonishingly sparse. Stars sit separated by unimaginable distances. Even within dense galactic regions, the space between stars remains vast enough to make the entire structure feel ghostly. If the sun were the size of a grain of sand, the nearest star would still be kilometers away. So despite NGC 6872 containing enormous numbers of stars, most of the galaxy is emptiness structured by gravity. That fact becomes even stranger when you realize your own body emerged from material forged inside ancient stars long before the solar system existed. Every carbon atom, every oxygen atom, every iron atom inside you once travelled through galaxies like these after being created in stellar interiors and supernova explosions. In a very literal sense, galaxies are where the ingredients for life are manufactured. Large galaxies like NGC 6872 contain generations upon generations of stars constantly recycling matter across cosmic timescales. Massive stars explode. New stars form from enriched gas. Planets emerge. Chemistry becomes more complex. Over enough time, perhaps biology appears. The galaxy itself may seem distant and abstract, but everything living on Earth depends on processes that began inside ancient galaxies billions of years ago, which gives giant spirals a strangely personal connection to us despite the impossible distances involved. And still, the scale remains difficult to emotionally process. 500,000 light years. Sometimes the brain hears such numbers and simply stops trying. So let us shrink the problem slightly. Light travels at about 300,000 kilometers per second, fast enough to circle Earth more than 7 times in 1 second. Sunlight reaches Earth in around 8 minutes. Light from Pluto takes several hours. Light from the nearest star beyond the Sun takes over 4 years. Already those scales feel large. Now imagine light travelling non-stop for over 500,000 years just across one galaxy. The species Homo sapiens has existed for only around 300,000 years, meaning a beam of light entering one side of NGC 6872 today would still not emerge from the opposite side even after the entire history of humanity had passed. That is the kind of scale astronomers deal with routinely, which may explain why they all develop slightly haunted expressions eventually. Space has a habit of breaking intuition. Even more remarkably, NGC 6872 is not stationary while all this happens. The galaxy itself moves through space. The stars inside it orbit continuously. Its companion galaxy continues interacting gravitationally with it. Galaxy groups around it evolve over billions of years. Everything moves, nothing rests. The universe is dynamic at every scale simultaneously, and yet from Earth, under ordinary human perception, the night sky appears calm and unchanging. The stars rise and set. Constellations hold their shapes. Galaxies remain faint smudges in telescopes. Cosmic evolution unfolds too, slowly for naked eyes to detect. Perhaps that is why astronomy feels so soothing to many people. It reveals enormous hidden motion beneath apparent stillness. NGC 687 too may look serene in photographs, but in reality it is the product of gravitational tension, tidal distortion, star formation, dark matter dynamics, and galactic interaction unfolding over hundreds of millions of years. A quiet giant, yes, but still a giant shaped by motion. And the deeper scientists looked into how such galaxies become so large without losing themselves completely, the more they realized that monsters like NGC 6872 are not accidents exactly. They are the result of long cosmic histories written in gravity across unimaginable spans of time, histories that eventually begin with the very first galaxies forming in the young universe itself. Long before astronomers understood what galaxies truly were, the night sky already contained more objects than human beings knew how to classify properly. Tiny smudges drifted through telescope eyepieces. Faint cloudy shapes appeared where stars should have been. Some turned out to be nebulae inside our own galaxy. Others became entire galaxies once telescopes improved enough to reveal their true nature. And somewhere among those distant faint structures sat NGC 6872, quietly waiting to be noticed. Which, in fairness, is not unusual behaviour for a galaxy located more than 200 million light-years away. One of the strange things about astronomy is that enormous objects are not necessarily easy to see. Size helps, certainly, but brightness matters far more from Earth's perspective. A nearby candle appears brighter than a distant mountain fire. In much the same way, relatively small nearby stars can outshine gigantic distant galaxies simply because they are closer. NGC 6872 is enormous, but it is also extremely far away. That combination creates an interesting effect. The galaxy contains staggering amounts of matter and light, yet from Earth it appears faint enough that most people will never encounter it naturally unless they deliberately go looking. And even then, finding it is not exactly simple. The galaxy lives in the constellation Parvo, a southern constellation whose name means the peacock. It is not among the sky's most famous star patterns. Nobody grows up hearing dramatic myths about Parvo, the way they do about Orion or Ursa Major. In fact, unless you live in the southern hemisphere or spend a suspicious amount of time studying star charts recreationally, there is a fair chance you have never heard of it at all. Parvo sits low in southern skies, surrounded by richer regions of the Milky Way, where stars crowd the darkness densely. Somewhere within that field lies NGC 6872, though lies makes it sound much more accessible than it actually is. Even through decent amateur telescopes, the galaxy remains challenging. You're not looking for a dramatic swirling pinwheel like those colourful long-exposure photographs astronomers love sharing online. Human eyes do not work that way in darkness. Through telescopes, distant galaxies usually appear as faint grey patches barely distinguishable from the surrounding blackness. which can feel slightly disappointing at first. You spend hours setting up equipment, waiting for darkness, aligning telescopes carefully, avoiding accidentally kicking expensive tripods, and finally, after all that preparation, you locate a galaxy containing hundreds of billions of stars. It looks vaguely like someone breathed gently on the eyepiece. Astronomy demands patience and imagination in equal measure. Still, there is something deeply satisfying about locating a real galaxy with your own eyes, even if it appears faint. The photons entering the telescope travelled for over 200 million years across intergalactic space before landing on your retina. Ancient light ends its impossible journey inside a sleepy human, standing in a dark field trying not to spill coffee on expensive equipment. That alone makes astronomy feel oddly personal sometimes. Professional observatories, of course, see much more. Modern telescopes equipped with sensitive digital instruments can reveal extraordinary detail inside NGC 6872. Long spiral arms emerge clearly. Bright regions of star formation glow throughout the structure. Dust lanes twist across parts of the disk. The smaller companion galaxy, IC 4970, appears nearby, visibly interacting with the giant spiral itself. And perhaps most strikingly, the galaxy looks stretched. Not subtly stretched either. It appears elongated in a way that immediately signals gravitational disturbance to astronomers. The arms extend asymmetrically outward, as though something enormous tugged on the galaxy and never quite let go afterward. Because something did. One of the reasons NGC 6872 became scientifically important is that it offers astronomers a remarkable laboratory for studying tidal interactions between galaxies. When galaxies pass near each other, gravity distorts their structures dramatically. Spiral arms lengthen, gas clouds compress, star formation intensifies. Entire streams of stars can be pulled outward into tidal tails extending across huge distances. NGC 6872 displays many of those effects beautifully, though beautifully is perhaps a slightly polite word for what amounts to a slow-motion gravitational struggle lasting hundreds of millions of years. Astronomers studying the galaxy realize that its immense size might partly result from these interactions. The encounter with IC 4970 likely stretched the galaxy outward, exaggerating the length of its spiral arms and helping create the extraordinary dimensions observed today. In other words, NGC 6872 did not simply grow quietly in isolation. It evolved through encounters, which is true of many things in the universe, honestly. Stars evolve through collisions of particles in stellar cores. Planets form through countless impacts between smaller bodies. Galaxies reshape themselves through interactions spanning billions of years. Even the elements inside your body were forged through violent stellar processes long before Earth existed. The cosmos builds complexity through motion and interaction constantly. And when astronomers observe NGC 6872, they are not merely looking at a static object frozen in time. They are seeing the aftermath of an ongoing galactic relationship still unfolding. That becomes even clearer when observing the galaxy across different wavelengths of light. Visible light reveals the stars and general structure. Infrared observations penetrate dust clouds and expose hidden regions of star formation. Radio telescopes detect enormous reservoirs of hydrogen gas spread throughout the galaxy's extended arms. Ultraviolet observations highlight young hot stars born relatively recently in cosmic terms. Each wavelength tells a slightly different story. Astronomy is less like taking photographs and more like assembling clues from multiple versions of reality layered on top of one another. And galaxies especially reward this kind of investigation because they are complicated ecosystems rather than simple objects. Stars form, evolve, explode, recycle matter, feed black holes, interact gravitationally, and generate magnetic fields simultaneously across incomprehensible distances. Trying to understand one giant galaxy properly requires observing nearly everything at once, which explains why astronomers occasionally look tired. One particularly interesting aspect of NGC 6872 involves the huge concentrations of gas spread through its elongated arms. Gas is important because gas creates stars. Without large reservoirs of hydrogen and other materials, galaxies gradually stop forming new stars and become quieter. Older systems dominated by aging stellar populations. NGC 6872 still contains active stellar nurseries. Clusters of young blue stars shine throughout parts of the galaxy, especially in regions affected by gravitational compression from the interaction with IC 4970. These stars burn hotter and brighter than older stars like our Sun, though they also live much shorter lives. Massive stars are a bit dramatic that way. They burn through their fuel rapidly, live fast by stellar standards, and often end in supernova explosions powerful enough to briefly outshine entire galaxies. Those explosions then scatter heavier elements back into surrounding space, enriching future generations of stars and planets. So while NGC 6872 appears ancient and stable overall, parts of it are continuously renewing themselves. Entire generations of stars are being born there even now. Perhaps at this very moment, somewhere inside one of those stretched spiral arms, a dense cloud of gas is collapsing inward under gravity, heating gradually until nuclear fusion ignites and a new star begins shining for the first time. The light from that birth will not reach Earth for another 212 million years. Astronomy has a strange relationship with now. Everything distant already happened long ago, yet from our perspective it arrives in the present. Looking deep into space means looking backward through time continuously. NGC 6872 appears tonight not as it exists currently, but as it existed before the first human beings appeared on Earth, which means the galaxy could already look different now. Its stars have moved, its companion galaxy has shifted position. New stellar explosions have occurred. Entire regions have evolved while the light remained in transit toward us. In a sense, all astronomy is archaeology performed with photons. The farther away we look, the older the evidence becomes, and that creates an oddly emotional dimension to observing distant galaxies. Every telescope image becomes both a portrait and a memory simultaneously. NGC 6872 especially encourages this feeling because of its sheer scale. The galaxy already feels ancient, stretched, patient and distant, even before you remember that every visible detail belongs to a past so remote it predates humanity entirely. Yet somehow, the light still arrives. That may be one of the most comforting things about the universe. Light persists. Across intergalactic emptiness, through cosmic expansion, across distances almost too large to mentally process, photons continue travelling faithfully until eventually encountering something capable of noticing them. Sometimes that something is a telescope. Sometimes it is a human eye. Finding galaxies like NGC 6872 also reminds astronomers how incomplete our understanding of the universe still remains. Giant galaxies exist. Dark matter shapes them invisibly. Gravitational interactions stretch them across impossible scales. Supermassive black holes lurk in their centres. Star formation rises and falls over billions of years, and despite all our scientific progress, enormous questions remain unanswered. What exactly is dark matter? Why do some spiral galaxies survive interactions while others lose their structure completely? How common are giant spirals this large? What determines whether galaxies continue forming stars or gradually fade into quiet stellar graveyards? Astronomy progresses by learning how much remains unknown. That is part of what makes it soothing rather than frightening for many people. The universe is not a solved puzzle. It is an unfolding mystery large enough to outlive every civilization that studies it. There will always be more sky. Of course, modern astronomy no longer relies only on isolated observers peering through eyepieces at faint smudges. Massive observatories around the world and in orbit collaborate continuously, generating detailed surveys of galaxies across enormous portions of the cosmos. Telescopes like the Hubble Space Telescope transformed our understanding of distant galaxies dramatically. Suddenly, astronomers could resolve structures once blurred into indistinct haze. Spiral arms sharpened, star clusters emerged, dust lanes became visible. Entire populations of distant galaxies appeared in astonishing detail. And still, every improvement in observation technology reveals additional complexity. The deeper scientists look, the stranger galaxies become. Some spiral galaxies rotate unexpectedly fast. Others contain inactive black holes far larger than expected. Some collide and merge violently. Others evolve quietly for billions of years. A few become enormous monsters like NGC 6872, whose dimensions seem to stretch ordinary galactic categories almost to breaking point. Which raises an interesting possibility. Perhaps galaxies are less orderly than astronomers once hoped. Human beings naturally enjoy classification systems. We like tidy categories because they make reality feel manageable. Spiral galaxy, elliptical galaxy, dwarf galaxy, barred spiral, lenticular, irregular. But nature rarely respects clean boundaries completely. NGC 6872 behaves like a reminder of that fact. It is technically a spiral galaxy, yes, but one reshaped so dramatically by interaction and scale that it begins occupying a category almost of its own, a quiet outlier drifting through deep space, and yet, despite all its unusual characteristics, the galaxy still obeys the same fundamental laws governing everything else in the cosmos. Gravity shapes it, angular momentum rotates it, nuclear fusion powers its stars, entropy gradually alters its structure over time. The same physics governing galaxies also governs oceans, clouds, campfires, falling leaves, and the electrical signals moving through your brain while you listen to this now. That continuity across scale may be one of science's most beautiful discoveries. The laws operating inside giant spiral galaxies are not separate from the laws shaping ordinary life on Earth. They're extensions of the same universe behaving consistently everywhere. The stars inside NGC 6872 are made from the same basic ingredients as the Sun. The atoms inside your body emerge from ancient stellar processes similar to those occurring there. Even the gravity stretching those enormous spiral arms is the same force currently holding you gently against the surface of Earth. Different scales, same universe. And perhaps that is why finding galaxies at the edge of the night sky feels strangely intimate despite the impossible distances involved. They remind us that we are not separate from the cosmos observing it. We are pieces of it becoming briefly aware of itself. Somewhere inside the enormous darkness beyond the Milky Way drifts a spiral galaxy, stretched across 500,000 light-years by gravity and time. And here on Earth, tiny conscious creatures built instruments capable of detecting its ancient light after a journey lasting hundreds of millions of years. That is a remarkable thing for the universe to permit. If you could somehow stand outside the history of the universe and watch galaxies evolving across billions of years, one thing would become obvious very quickly. Galaxies not born enormous. Even giants like NGC 6872 began much smaller once upon a time. That may sound strangely obvious at first. Everything starts small. Trees begin as seeds. Mountains begin as shifting rock. Civilizations begin with a few people trying very hard not to freeze during winter. But galaxies operate on scales so vast that it becomes easy to imagine them as permanent fixtures rather than evolving systems with long, complicated histories. In reality, galaxies spend billions of years growing, colliding, feeding, stretching, and reshaping themselves through gravity. And gravity, as we have gently established already, is incredibly patient. The story begins shortly after the Big Bang, back when the universe itself was far younger, denser, and dramatically less organized than it is today. At first, there were no stars, no galaxies, no planets, and certainly no sleepy humans lying in bed listening to astronomy videos while wondering whether they remembered to answer an email earlier. There was mostly hydrogen, a little helium, tiny fluctuations in density, and an enormous amount of darkness. For hundreds of millions of years, the universe contained no stars at all. Cosmologists sometimes call this period the Cosmic Dark Ages, which sounds appropriately dramatic for a time when the cosmos had not yet figured out how to switch the lights on. Eventually, gravity began gathering slightly denser regions of gas together. Tiny variations left over from the early universe became larger over time. Regions with more matter attracted additional matter. Gas clouds collapsed inward. Temperatures rose. Pressure increased. And then the first stars ignited. Those early stars were different from most stars alive today. They were likely enormous, extremely hot, and very short-lived. Without heavier elements present yet, early star formation behaved differently. Massive stars burned through their fuel quickly and exploded violently as supernovae, scattering the first heavier elements into surrounding space. Carbon, oxygen, iron, silicon. The ingredients future planets and life would eventually require. In a sense, the universe spent its early years learning chemistry. Around those first generations of stars, gravity continued gathering matter into larger structures. Small proto-galaxies formed. These primitive systems merged repeatedly, growing gradually into more recognizable galaxies over time. This is one of the key ideas in modern cosmology. Galaxies grow hierarchically. Small things merge into larger things, then those larger things merge into even larger things. The universe builds structure almost the way. Rivers gather water from streams. Tiny fluctuations become clouds. Clouds become stars. Stars gather into galaxies. Galaxies collect into groups and clusters. Clusters form superclusters and cosmic filaments stretching across unimaginable distances. Everything accumulates. And somewhere along this enormous chain of cosmic construction projects, galaxies occasionally become monsters. NGC 6872 is one of those monsters, though perhaps monster sounds harsher than intended. The galaxy is not frightening exactly, it is simply excessive in scale. A spiral system stretched so large that astronomers still study it, partly because it challenges expectations about how giant spirals should behave. Most spiral galaxies do not become this enormous. That matters. Astronomers often learn the most from outliers, because outliers reveal which rules are flexible and which are fundamental. If every spiral galaxy looked exactly the same, understanding galactic evolution would actually be easier, but less interesting. Instead, nature produces enormous diversity. Some galaxies remain tiny dwarfs containing only a few billion stars. Others become giant ellipticals with trillions. Some spirals stay relatively orderly for billions of years. Others collide repeatedly until their structures dissolve into chaotic mergers. And a few systems like NGC 6872 somehow grow extraordinarily large while still maintaining recognizable spiral architecture. That last part is especially important because spiral galaxies are delicate compared to giant ellipticals. People often imagine galaxies as rigid objects, but they are really dynamic systems balancing enormous gravitational forces. Spiral arms persist through complicated interactions involving rotation, density waves, gas dynamics, star formation, and dark matter halos. As galaxies grow larger and experience more interactions, maintaining those elegant spiral structures becomes harder. Collisions distort them. Mergers scramble them. Star formation changes their internal dynamics. Black holes influence central regions. Dark matter shapes overall stability invisibly. Galaxies are not static collections of stars. They are ecosystems evolving continuously across billions of years. Which raises the obvious question: how exactly does something like NGC 6872 become so large without completely losing itself along the way? Part of the answer involves location. Galaxies do not evolve in isolation. They live within larger gravitational environments. Some occupy crowded clusters where interactions and mergers happen frequently. Others drift through quieter regions of space with fewer neighbours nearby. NGC 6872 exists within a galaxy group environment where interactions occur, but not necessarily the catastrophic repeated collisions common in dense galaxy clusters. That balance matters. Too much isolation, and a galaxy may never accumulate enough material to grow enormous. Too many violent mergers and spiral structure may vanish entirely. Somehow NGC 6872 appears to have occupied a middle ground, where growth remained possible without complete structural destruction, though without destruction might again be slightly optimistic wording considering the galaxy clearly looks stretched and disturbed already. Still, it survived as a spiral. That survival probably depended heavily on angular momentum. Angular momentum is one of those wonderfully stubborn properties in physics that refuses to disappear easily. Once matter begins rotating, it tends to keep rotating unless acted upon strongly enough to change direction. Galaxies form from enormous rotating clouds of matter collapsing under gravity. As those clouds contract, rotation speeds up, much like a spinning ice skater pulling their arms inward. Except in this case, the arms contain billions of stars and enough gas to form entire solar systems for billions of years. The result is a rotating galactic disk. Inside that disk, stars orbit the center, while gas clouds collide, compress, and create new stars continuously. Spiral patterns emerge through density waves moving through the rotating material. But larger galaxies require more than just rotation. They require mass, an extraordinary amount of it. The visible stars inside NGC 6872 already represent enormous quantities of matter. Add the gas reservoir spread through its extended arms and the total grows even larger. Then include the invisible dark matter halo surrounding the galaxy, and suddenly the entire system becomes immense beyond ordinary comprehension. Dark matter again plays a critical role here. Without dark matter, galaxies likely could not grow into structures this large while remaining gravitationally stable. Observations suggest galaxies sit inside vast halos of dark matter, extending far beyond visible stars. These halos help stabilize rotating disks and influence how galaxies interact gravitationally over cosmic timescales. And yet scientists still do not know exactly what dark matter is. That remains one of modern astronomy's greatest mysteries. Imagine trying to understand how cities form while being unable to identify most of the material holding the buildings together. That is roughly the situation astronomers face with galaxies. They can observe dark matter's gravitational effects clearly, they just cannot see the stuff itself. Which means giant galaxies like NGC 6872 are partly built from invisible architecture. A little unsettling perhaps, though also oddly elegant. The universe does seem fond of hidden structures. Another important factor in galactic growth involves gas supply. Galaxies need gas to continue forming stars. Without fresh gas, star formation gradually slows as existing material becomes locked inside aging stellar populations. Some galaxies effectively burn through their fuel too quickly and become red and dead, dominated by old cooler stars with little ongoing star formation. NGC 6872 avoided that fate. The galaxy still contains significant reservoirs of hydrogen gas, especially throughout its enormous spiral arms. Observations show active star formation occurring in multiple regions, particularly where gravitational interactions compressed gas clouds strongly enough to trigger collapse. This is another fascinating aspect of galactic evolution. Interactions that appear destructive can also create. When galaxies pass near each other, tidal forces stretch structures outward and compress gas simultaneously. Those compressed regions become stellar nurseries where entirely new generations of stars ignite. Gravity tears galaxies apart while helping build new stars inside them at the same time. The universe rarely does only one thing at once, and in galaxies as large as NGC 6872, these processes unfold across extraordinary distances. Entire star-forming regions inside the galaxy may span thousands of light years. Stellar clusters emerge within gigantic molecular clouds, larger than many smaller galaxies altogether. Scale changes everything in astronomy. A cloud of gas inside NGC 6872 might contain enough material to create millions of stars eventually. Supernova explosions inside one region can trigger additional waves of star formation nearby. Black holes at galactic centers influence surrounding dynamics. Magnetic fields thread through enormous volumes of interstellar space, and all of it evolves slowly enough that galaxies appear calm from our perspective. That calmness can be deceptive. Imagine watching a forest grow using only photographs taken once every 100,000 years. Trees would seem to appear magically. Rivers would shift unexpectedly. Entire landscapes would transform between images. Galaxies operate similarly. Their timescales are simply too large for human intuition. NGC 6872 likely spent billions of years accumulating mass gradually through mergers, gas accretion, and gravitational interactions before becoming the enormous spiral observed today. Even now its evolution continues. The interaction with IC 4970 is still reshaping the system. Stars continue orbiting. Gas clouds continue collapsing. Supernovae continue exploding. Black holes continue feeding quietly at galactic centers. Nothing has stopped. The galaxy only appears stable because humans live far too briefly to witness galactic motion directly. And perhaps that is one reason astronomy feels strangely relaxing late at night. It introduces timescales large enough to soften ordinary urgency. Galaxies are in no hurry. NGC 6872 has existed for billions of years already. Its stars rotated through countless orbits before Earth even formed. Entire species emerged and vanished on our planet, while light travelled from the galaxy toward us. Compared to that, most daily anxieties begin feeling pleasantly temporary, not meaningless exactly, just smaller. Astronomers studying galactic growth also discovered that giant galaxies influence their environment significantly. Massive galaxies affect surrounding gas distributions, gravitational dynamics, and even neighbouring galaxies over enormous distances. NGC 6872 does not merely occupy space passively. Its gravitational presence shapes the region around it continuously. And that influence extends farther than visible light alone suggests, because dark matter halos stretch well beyond galactic disks themselves. The visible galaxy is only the luminous centre of a much larger gravitational structure. This idea can feel strange initially because human beings naturally associate objects with visible boundaries. A mountain ends visibly, a lake has shores, a building occupies defined space. Galaxies blur those expectations. Where exactly does a galaxy end? At the edge of visible stars? At the edge of detectable gas? At the boundary of the dark matter halo? Astronomers debate such questions constantly, because galaxies are not solid objects with clean borders. They fade gradually into surrounding space. NGC 6872 especially demonstrates this beautifully because its elongated arms stretch outward so far that the galaxy almost appears to dissolve into darkness at the edges, and still gravity holds it together. Barely perhaps, but successfully enough. One particularly interesting aspect of giant spiral galaxies involves survivability. Large galaxies often consume smaller companions over time. Tiny dwarf galaxies drifting too close may become gravitationally disrupted entirely, their stars absorbed into larger systems gradually. The Milky Way itself is currently consuming smaller dwarf galaxies even now. Galactic cannibalism sounds dramatic because it is dramatic, But again, everything happens very slowly. Stars rarely collide directly during mergers because galaxies are mostly empty space. Instead, gravitational interactions redistribute stellar orbits gradually until structures combine into larger systems. NGC 6872 almost certainly absorbed smaller galaxies throughout its history. Those ancient mergers likely contributed additional mass and helped shape its evolution into the giant spiral seen today, which means part of the galaxy's enormous size comes from long cosmic accumulation, a history written in mergers. And perhaps that is fitting because the universe itself seems to build larger structures continuously from smaller beginnings. At every scale, complexity emerges through gathering, interaction, and time. Lots and lots of time. Still, even among giant spirals, NGC 6872 remains unusual enough that astronomers continue studying it carefully. The galaxy stretches expectations regarding spiral structure stability, interaction dynamics, and galactic growth processes themselves. It is not merely large, it is instructively large, and the more scientists examined how its extraordinary arms formed and survived, the clearer it became that one particular encounter may have reshaped the galaxy more dramatically than any other. Galaxies do not collide the way planets do. That is one of the first strange things astronomers have to explain whenever the subject comes up. People naturally imagine impact, fire, explosions, objects smashing directly into each other like cosmic car accidents with slightly worse insurance paperwork. But galaxies are far too empty for that kind of collision most of the time. Even in dense galactic regions, the distances between stars are enormous. If the Sun were reduced to the size of a marble, the nearest star would still sit hundreds of kilometers away. So when galaxies pass through one another, individual stars almost always miss completely. And yet, despite that emptiness, galactic collisions remain among the most powerful events in the universe. Because gravity does not require contact, it only requires mass and patience. And NGC 6872 offers one of the most extraordinary examples astronomers have ever observed of what gravity can do to a spiral galaxy over time. At some point in the distant past, another galaxy drifted too close. That smaller companion, IC 4970, likely approached NGC 6872, slowly by human standards but incredibly fast on galactic scales. Not fast enough to destroy the giant spiral outright, not fast enough to scatter it into chaos completely. Instead, the interaction settled into something almost more dramatic, a long gravitational pulling, the kind of interaction that reshapes galaxies over hundreds of millions of years. And what makes this especially fascinating is that astronomers can still see the fingerprints of that encounter today. The enormous stretched spiral arms of NGC 6872 are not random structures. They are tidal distortions, immense rivers of stars and gas pulled outward by gravity itself. In a sense, the galaxy was stretched like dough. Though admittedly dough usually does not contain hundreds of billions of stars, gravity works in wonderfully strange ways on galactic scales because it amplifies tiny differences relentlessly over time. A slight imbalance becomes a distortion becomes an elongated arm. Entire star-forming regions shift position gradually, gas clouds compress, stellar orbits change, and because everything happens slowly, galaxies often survive these encounters instead of being destroyed instantly. That survival is important. NGC 6872 still looks like a spiral galaxy because the interaction with IC 4970 was disruptive but not catastrophic. Had the collision been more direct or violent, the result might have become an elliptical galaxy instead, with spiral structure erased entirely. Galaxies are surprisingly fragile that way. The elegant spiral patterns people admire in telescope images are not permanent architectural features carved into the universe forever. They are temporary arrangements maintained through delicate balances involving rotation, gravity, gas dynamics, dark matter and ongoing star formation. Disturb those balances strongly enough, and spirals vanish, which makes the survival of NGC 6872's structure particularly remarkable considering how enormous and stretched the galaxy became. Astronomers studying simulations of galactic interactions discovered that encounters like this generate something called tidal forces. Tidal forces happen because gravity weakens with distance. One side of a galaxy experiences slightly stronger gravitational pull than the opposite side during a close encounter. The same thing happens on Earth. Ocean tides exist because the Moon pulls slightly harder on the side of Earth facing it than on the opposite side. Water responds visibly because liquids move easily. Galaxies respond too. Except instead of oceans rising and falling gently along coastlines, entire spiral arms become elongated across hundreds of thousands of light years. Scale changes the drama considerably, and in NGC 6872, those tidal effects became enormous. The galaxy's spiral arms extended outward into long, graceful structures filled with stars, gas, and active star-forming regions. Some portions appear almost impossibly thin considering their length. Others contain bright clusters of young stars formed after gravitational compression-triggered collapse within giant gas clouds. Gravity simultaneously stretched the galaxy apart and helped create new stars inside it, which feels like a very universe-like thing to do, honestly. Destruction and creation often arrive together in astronomy. Supernovae destroy stars while scattering elements needed for planets and life. Black holes consume matter while shaping galaxies around them. Colliding galaxies trigger chaos while igniting waves of star formation. The cosmos rarely separates endings from beginnings neatly. In the case of NGC 6872, the interaction with IC 4970 likely triggered widespread star formation throughout the elongated arms. As gas clouds compressed under tidal forces, dense regions collapsed inward until nuclear fusion ignited inside newborn stars. Many of these young stars shine blue-white and extremely bright because massive stars burn hotter and faster than smaller ones like our Sun. They live relatively short lives, sometimes only millions of years, before exploding as supernovae, which means parts of the galaxy currently glow with young stellar populations born specifically because gravity disrupted the system. Without the collision, some of those stars might never have formed. There is something strangely comforting about that. Even cosmic disturbance creates opportunities for new structures to emerge. Of course, comforting may not be the word astronomers use while modelling gravitational interactions involving billions of stars and dark matter halos. Those simulations become extraordinarily complicated very quickly. To understand galactic collisions properly, scientists use supercomputers capable of calculating gravitational interactions between enormous numbers of particles over billions of years. Simulations track stars, gas clouds, dark matter distributions, and orbital motions simultaneously, and even then, galaxies remain difficult. Tiny differences in initial conditions can dramatically alter outcomes over cosmic timescales. Slight changes in approach angle, velocity, mass ratio, or dark matter structure influence how collisions unfold. Some encounters produce spectacular tidal tails stretching far into space. Others trigger central starbursts. Some feed supermassive black holes. Others completely scramble spiral structure into elliptical galaxies. NGC 6872 appears to occupy a fascinating middle ground, where tidal distortion became extreme, while the overall spiral identity survived. Barely perhaps, but magnificently. One reason astronomers find this especially valuable is because galactic interactions were far more common in the early universe. Back then, galaxies lived closer together. Space itself had expanded less. Encounters happened frequently as young galaxies assembled into larger structures through mergers and interactions. The modern universe is calmer in comparison. Galaxies remain separated by enormous distances now. The average spacing between large galaxies feels almost lonely. But billions of years ago, collisions and near misses shaped galactic evolution continuously, which means systems like NGC 6872 offer glimpses into processes that once dominated cosmic history. In a way, the galaxy acts like a surviving demonstration of ancient galactic behaviour, and the more astronomers observed its structure carefully, the more they realised something interesting about spiral galaxies in general. Spiral structure itself may partly depend on ongoing disturbance. At first, this sounds counterintuitive. People often associate spirals with order and collisions with disorder, but galaxies are dynamic systems. Perfectly isolated rotating disks may actually lose spiral patterns gradually over time. Interactions help maintain complexity. Passing galaxies generate gravitational waves moving through galactic disks. Gas clouds compress. Density patterns strengthen. Star formation lights up spiral arms brightly. Motion itself helps sustain visible structure. Without interactions, some galaxies might become smoother and less dramatic eventually. So oddly enough, collisions may help preserve the very beauty they appear to threaten. Gravity again proving wonderfully complicated, and gravity's influence extends far beyond visible stars. Dark matter will most certainly shape this interaction too. Both NGC 6872 and IC 4970 likely sit inside enormous invisible halos of dark matter, extending well beyond their visible structures. When galaxies interact, those halos interact gravitationally as well, influencing orbital dynamics and tidal effects profoundly. In fact, some simulations suggest dark matter halos may absorb part of the energy from galactic encounters, helping stabilize visible structures during collisions, which means invisible matter may have helped prevent NGC 6872 from tearing itself apart completely. Astronomy occasionally sounds less like physics and more like mythology if you say things slowly enough. An invisible substance surrounds giant galaxies and quietly protects them from gravitational destruction, while shaping their evolution over billions of years. Entire civilizations in ancient history would absolutely have turned dark matter into a deity. Still, despite all the complexity involved, one fact remains beautifully simple. Gravity shapes galaxies. Everything else follows from that. Stars orbit because gravity holds them. Gas clouds collapse because gravity compresses them. Spiral arms persist because gravity organizes motion. Galaxies merge because gravity pulls them together. Black holes dominate galactic centers because gravity becomes overwhelming there. And NGC 6872 became enormous, partly because gravity stretched it slowly across deep space. Perhaps the most astonishing part is the timescale involved. Human beings instinctively think in minutes, days, years, perhaps. We struggle emotionally with waiting a month for packages sometimes. Galactic interactions unfold across spans of time so vast they almost stop feeling like events at all. The encounter shaping NGC 6872 likely developed over hundreds of millions of years. Hundreds of millions. During that interval on Earth, continents shifted. Entire ecosystems emerged and vanished. Dinosaurs disappeared, mammals diversified, primates evolved. Human ancestors appeared extraordinarily late in the timeline. Meanwhile, the galaxies kept pulling on each other continuously, slowly, quietly, relentlessly. This is one reason astronomy changes how people think about motion. Things do not need to happen quickly to be dramatic. Some of the largest transformations in the universe occur so gradually that they appear peaceful. A mountain erodes grain by grain. A galaxy stretches star by star. A universe expands second by second. And eventually immense change emerges from steady persistence. NGC 6872 embodies that beautifully. It is not a violent-looking object despite its turbulent history. The galaxy appears graceful, almost delicate in some telescope images. Its elongated arms sweep outward elegantly through darkness. But hidden inside that elegance lies gravitational tension accumulated across incomprehensible spans of time. The structure exists because billions of stars responded collectively to invisible forces over cosmic history. And perhaps that is what makes spiral galaxies so emotionally compelling to human beings. They combine enormous power with visible order. Hurricanes are powerful but chaotic. Explosions are powerful but brief. Spiral galaxies feel different. They rotate with calmness despite containing enough energy and matter to overwhelm imagination completely. NGC 6872 especially captures that contradiction. It is one of the largest known spiral galaxies in existence, stretched by gravitational interaction into extraordinary dimensions, yet it still looks serene from afar. A giant quietly turning through darkness. Of course, the collision with EC 4970 may not represent the galaxy's final transformation either. Galactic evolution continues. Eventually further interactions could distort the structure more dramatically. Spiral arms may fade, additional mergers may occur, star formation could slow as gas reservoirs diminish. Over billions more years, the galaxy may evolve into something entirely different. Nothing in the cosmos stays fixed forever. Even galaxies age. The stars inside NGC 6872 already contain multiple generations spanning enormous differences in age. Some are ancient red stars formed billions of years ago near the galaxy's early beginnings. Others are young blue stars born relatively recently due to tidal compression during the interaction. Different eras of cosmic history coexist inside one galaxy simultaneously. And somewhere within all those rotating stellar populations likely sits a supermassive black hole at the galaxy's centre, quietly influencing surrounding matter while remaining almost completely invisible. Because no matter how large a spiral galaxy becomes, gravity always seems to gather something even stranger at the centre eventually. The spiral arms of NGC 6872 are so long that they almost stop looking like spiral arms after a while. Instead, they begin resembling streams, rivers of stars stretching outward across darkness. And the farther astronomers study those enormous structures, the more they realize something remarkable. These outer regions were not quiet leftovers fading gently into empty space. They were active, dynamic, filled with enormous clouds of gas where entirely new generations of stars were still being born. Which feels slightly unfair somehow. Most galaxies would already be considered astonishing at a fraction of this scale. But NGC 6872 not only grew gigantic, it also managed to keep large portions of its outer arm alive, with ongoing star formation. The galaxy refused to become quiet. And that matters because spiral arms are not merely decorative patterns. They are the working regions of spiral galaxies, the places where gas compresses, stars ignite, and stellar evolution reshapes galactic structure continuously over time. In many ways, spiral arms are factories. Not factories in the noisy industrial sense filled with conveyor belts and coffee, machines that mysteriously stop working every Monday morning. More like enormous cosmic ecosystems where gravity organizes matter into cycles lasting billions of years. Gas becomes stars. Stars create heavier elements. Massive stars explode. Their material spreads outward. New stars form from enriched gas, and the process continues again and again across cosmic history. Inside NGC 6872, those processes unfold on extraordinary scales. The galaxy's spiral arms extend outward for hundreds of thousands of light years, containing immense reservoirs of hydrogen gas and dust. Observations in ultraviolet light reveal bright regions packed with young hot stars, especially along the elongated tidal arm shaped by the interaction with IC 4970. These regions glow because young massive stars are incredibly energetic. Blue stars especially burn at extremely high temperatures. They radiate huge amounts of ultraviolet light and shine brilliantly despite their relatively short lives. In astronomical terms, massive stars are somewhat reckless. They consume fuel rapidly and often explode after only a few million years. The Sun, by comparison, is calm and conservative. It has existed for around 4.6 billion years already, and still sits comfortably near middle age by stellar standards. A massive blue star might live only a tiny fraction of that time before ending in a supernova explosion, which means many of the bright young stars inside NGC 6872's arms are temporary visitors in cosmic terms, brilliant short-lived flashes scattered across the galaxy's enormous structure, and they form because giant molecular clouds collapse under gravity. That process begins inside cold, dense regions of interstellar gas. Hydrogen atoms drift through enormous clouds, spanning dozens or even hundreds of light years. Tiny disturbances compress some regions slightly more than others. Gravity amplifies those differences gradually. Denser regions attract additional material. Pressure rises. Temperatures increase. Eventually, the collapsing core becomes hot enough for nuclear fusion to ignite. A new star is born, simple in principle, ridiculously complicated in practice. Star formation involves turbulence, magnetic fields, radiation pressure, shock waves, angular momentum, chemistry, and gravity all interacting simultaneously. Astronomers still debate many details because the process becomes incredibly messy once examined closely. Nature enjoys complexity whenever possible. Still, one thing remains clear. NGC 6872 contains enormous amounts of raw material for star formation, especially within its stretched spiral arms. Those tidal structures created by gravitational interaction are not empty distortions. They contain active stellar nurseries scattered throughout their length, which means the collision that stretched the galaxy also helped create entirely new stars along its outer edges, gravity tearing and building simultaneously again. There is something wonderfully consistent about that pattern throughout the universe. Disturbance often creates structure rather than simply destroying it. And nowhere does that become more visually dramatic than in giant spiral galaxies. The spiral arms themselves operate like density waves moving through galactic disks. This is one of the stranger concepts in astronomy, because spiral arms are not fixed objects made from the same stars forever. Instead, stars move through the arms. A helpful comparison is traffic. Imagine cars entering a traffic jam on a highway. Individual cars move forward continuously, but the traffic jam itself persists as a region of higher density. In a similar way, stars and gas drift through spiral arms, while the overall spiral pattern remains. Gas clouds entering those denser regions become compressed. Compressed gas triggers star formation. Young bright stars illuminate the arms visibly. The galaxy appears to maintain stable spiral structure, even though individual stars continue orbiting independently. Astronomy occasionally solves mysteries using examples suspiciously close to ordinary commuting problems, though admittedly traffic jams rarely span hundreds of thousands of light years. In NGC 6872, the process becomes even more dramatic because gravitational interactions amplified the spiral structure enormously. The galaxy's elongated arms contain huge regions where gas density increased enough to stimulate large-scale star formation. Some star clusters inside those regions are relatively young, only a few million years old. That sounds ancient by human standards, of course, but astronomically, it is practically infancy. Dinosaurs vanished around 66 million years ago, so a 5 million-year-old star cluster would be younger than the Himalayan mountain range. Scale changes perspective constantly in astronomy, and perhaps nowhere is that more noticeable than when discussing stellar populations inside giant galaxies. NGC 6872 contains stars spanning enormous differences in age simultaneously. Ancient red stars orbit near the centre. survivors from much earlier periods of galactic evolution. Young blue stars shine in outer tidal arms, born from recent gravitational disturbances. Some stars likely formed before Earth existed. Others formed while mammals were already evolving. Different eras of cosmic history coexist together inside one rotating system, and all of it moves continuously. That movement is another astonishing feature of spiral galaxies people rarely think about carefully. Every star inside NGC 6872 orbits the galactic centre, but stars farther from the centre travel different paths and speeds than stars closer inward. The galaxy rotates, slowly from human perspective, rapidly from cosmic perspective. Our Sun takes roughly 225 million years to complete one orbit around the centre of the Milky Way. NGC 6872 likely operates on similarly immense rotational timescales, which means if intelligent civilizations exist somewhere inside its spiral arms, entire species might rise and disappear before completing a single galactic year. That thought has a way of softening urgency again. Galaxies move too slowly to care about rushing. Yet despite those calm appearances, the outer arms of NGC 6872 are extraordinarily active environments. Massive stars emit powerful stellar winds. Supernova explosions shock surrounding gas clouds. Radiation from hot young stars reshapes nearby nebulae constantly. The edges of the galaxy are alive with energy, and because the arms stretch so far outward, star formation occurs at distances where many galaxies would already fade into sparse stellar outskirts. This is one reason astronomers find NGC 6872 so fascinating. The galaxy pushes spiral structure to extremes without entirely losing coherence. Its outer arms remain recognizable, active and star-forming despite their enormous extent. The system almost seems too large to function properly, yet somehow it does, at least for now. Of course, star formation itself cannot continue forever. Galaxies gradually consume their gas reservoirs over billions of years. Some replenish material through mergers or inflows from surrounding intergalactic space. Others eventually exhaust enough fuel that star formation slows dramatically. Astronomers sometimes describe aging galaxies as quenching, which sounds less like astrophysics and more like somebody calming down a dragon with herbal tea. But the concept matters. Young active galaxies tend to appear bluer because they contain many hot young stars. Older quieter galaxies appear redder because mostly cooler long-lived stars remain. NGC 6872 still shows substantial activity, especially in its extended arms. But eventually even giant spirals evolve toward quieter futures. The universe changes everything eventually. Still, the current state of NGC 6872 offers astronomers a remarkable opportunity to study large-scale star formation under extreme conditions. By examining how stars form inside those stretched tidal arms, scientists learn more about how galactic interactions influence stellar birth rates and structural evolution. Observations using radio telescopes reveal huge hydrogen gas distributions throughout the system. Infrared observations penetrate dust clouds hiding young stars. Ultraviolet studies highlight newly formed stellar populations. Every wavelength exposes different layers of galactic life. And one particularly intriguing discovery involves the sheer size of some star-forming regions inside the arms. These are not tiny isolated nurseries. Some regions span enormous distances and contain huge clusters of young stars. Entire stellar populations emerge together. Imagine standing on a planet orbiting a star near the outer edge of NGC 6872. The night sky there might look extraordinary. Dense fields of stars would stretch across enormous galactic arms overhead. Bright blue star clusters could illuminate surrounding gas clouds faintly. Neighbouring stellar nurseries might glow softly through interstellar dust. And beyond it all, the rest of the galaxy would continue extending across space almost impossibly far in both directions. though admittedly any civilization living there would probably consider such skies normal eventually. That may be one of the strangest habits of intelligent life. Whatever environment surrounds us gradually becomes ordinary, no matter how absurd it truly is. Human beings adapted to living on a rotating planet orbiting a nuclear star inside a galaxy containing hundreds of billions of suns, and most of us still spend alarming amounts of time worrying about misplaced charges. Perspective is fragile. Astronomy helps restore it a little, especially galaxies like NGC 6872, because their sheer scale forces the brain into unfamiliar territory. You cannot emotionally process 500,000 light-years properly. Eventually the mind stops trying to convert the numbers into direct experience, and instead settles into awe quietly. Perhaps that is why giant galaxies feel soothing rather than frightening to many people. They're too large for ordinary anxiety, and the spiral arms themselves encourage that feeling, because they appear graceful despite the enormous forces shaping them. Long arcs of stars sweep outward through darkness calmly, while gravity orchestrates structures across incomprehensible distances. There is rhythm there, not poetic rhythm exactly, more physical rhythm: rotation, collapse, fusion, explosion, recycling, motion. The universe repeats processes constantly at every scale. Clouds form and disperse, stars ignite and die, galaxies rotate and evolve. Everything changes while following patterns simultaneously. Inside NGC 6872, those patterns become visible across astonishing distances. The galaxy's outer arms contain evidence of gravitational interaction, ongoing star formation, dark matter influence, stellar evolution, and rotational dynamics all woven together into one enormous structure. A living galaxy in the broadest sense. Not alive biologically, of course, but active, responsive, evolving continuously. And somewhere inside those endless spiral arms, countless stars already possess planetary systems of their own. Astronomers now know planets are extraordinarily common throughout the universe. Most stars likely host them in some form, which means giant galaxies like NGC 6872 probably contain unimaginable numbers of worlds, rocky planets, gas giants, frozen moons, ocean worlds perhaps, planets orbiting binary stars, planets drifting freely without stars at all, entire landscapes hidden inside those distant spiral arms, forever beyond direct human reach. That realization changes galaxies slightly once you think about it long enough. They stop feeling like distant abstract structures and begin feeling more like enormous archipelagos of possibility. Picture yourself beginning at one outer edge of NGC 6872, not in the bright center, not near the thick crowded bar where stars gather more densely, but far out along one of its stretched spiral arms, where the galaxy thins gradually into the surrounding dark. You're not standing on anything yet, because galaxies do not provide convenient viewing platforms, which is a shame. A small balcony at the edge of a 500,000 light-year wide spiral galaxy would be quite the tourist attraction, though the travel time might make the brochure slightly discouraging. Still, imagine it gently. You begin near the far tip of one of those immense arms, a region shaped by gravity, disturbed by the passing pull of IC4970, and brightened here and there by young stars. Around you, space looks mostly empty, because space is mostly empty, even inside a galaxy. Stars are not packed shoulder to shoulder like lanterns in a crowded street. They are separated by distances so huge that the mind almost gives up trying to arrange them. If you were inside one of NGC 6872's outer arms, the nearest star might still be light years away. The next one after that might be farther still. A galaxy can contain hundreds of billions of stars and still be emptier than almost anything human beings can experience directly. It is one of those cosmic facts that sounds wrong until you think about it carefully. From far away, a galaxy looks solid, luminous, structured. Up close, it becomes scattered points of light in enormous darkness. That is true of the Milky Way too. We live inside a spiral galaxy, and yet most of the sky above us appears dark. The stars are there, of course, but separated by distances so large that even their combined presence leaves plenty of room for night. Now, make that feeling larger, much larger. NGC 6872 spans about 522,000 light-years from one outstretched arm to the other, making it more than 5 times the diameter of the Milky Way by the measurement that brought it attention, as the largest known spiral galaxy in 2013. It lies roughly 212 million light-years from Earth, in the southern constellation Pavo, and its unusual shape is strongly linked to its interaction with the smaller galaxy IC4970. That number, 522,000 light-years, is easy to say and almost impossible to feel. A light-year is not a measure of time, although the name does enjoy causing mild confusion. It is a measure of distance. 1 light-year is the distance light travels in 1 year, moving at about 300,000 kilometers per second. Light can cross the distance from Earth to the Moon in just over 1 second. It reaches us from the Sun in a little over 8 minutes. It crosses the distance from the Sun to Neptune in a few hours. But across NGC 6872 from one end of its longest visible structure to the other, light needs more than 500,000 years. More than 500,000 years just to get across one galaxy. Not across the universe, not across a galaxy cluster, not across the gap between distant cosmic walls. Just one spiral galaxy. The human brain does not come equipped with a natural setting for that. So let us walk toward it slowly, one scale at a time. If you could travel at the speed of light, which you cannot because physics has several firm opinions about massive objects attempting that sort of thing, crossing Earth would be almost instantaneous. Circling the planet would take a fraction of a second. The Moon would be barely more than 1 second away. The Sun would be 8 minutes away. Pluto, depending on where it is in its orbit, would be several light hours away. The nearest star system, Alpha Centauri, would take more than 4 years. Already that feels vast. 4 years travelling at the fastest possible speed in the universe simply to reach the nearest neighbouring star. At ordinary spacecraft speeds, of course, the journey becomes far longer. Our current machines are impressive, but compared with interstellar distances, they move like very determined dust. Now continue outward. The Milky Way is about 100,000 light-years across, depending on how its faint outskirts are defined. A beam of light travelling from one side to the other would need about 100,000 years to complete the crossing. When that same light began its journey, early humans on Earth were living in a world very different from ours. No cities, no agriculture, no telescopes, no alphabet, no late-night astronomy videos playing quietly in the background. By the time the light crossed the Milky Way, human civilization as we know it would still have been waiting far ahead in the future. NGC 6872 multiplies that scale several times over. A light beam entering one far edge of the galaxy would travel through the long outer arm, through regions of young star clusters, across dust lanes, past giant gas clouds, into the broader disk, through the central structure, out into the opposite arm, and still continue for hundreds of thousands of years before reaching the far side. During that journey, entire species could evolve and disappear on a planet like Earth. Ice ages could come and go, continents could shift, mountains could rise and erode. Human beings could appear, invent language, build societies, discover mathematics, launch spacecraft, and then spend a surprising amount of their time deciding whether to snooze an alarm for 9 more minutes. And the light would still be crossing. There is something deeply calming about a scale that makes even history feel brief. Not because human history is unimportant, but because the universe provides a wider room for it. Our lives take place inside minutes and years. Galaxies live inside hundreds of millions and billions of years. NGC 6872 does not rush because nothing about its structure can happen quickly. A star orbiting within that galaxy may need hundreds of millions of years to complete one path around the centre. A cloud of gas may drift through a spiral arm over spans longer than mammals have dominated Earth. A tidal distortion created by another galaxy's gravitational pull may remain visible long after the original close approach has become ancient history. Inside NGC 6872, motion exists everywhere, but it is motion slowed by scale. That is one of the strangest things about imagining crossing. If you could somehow move through the galaxy at ordinary human spacecraft speeds, the journey would be meaningless as travel. You would never cross it. Not in one lifetime, not in 1,000, not in the lifetime of a civilization. The distances are simply too large. Even at light speed, the journey would exceed the span of our species so far. Homo sapiens has existed for roughly 300,000 years. Light needs about 522,000 years to travel from one tip of NGC 6872's extended arms to the other. So the full crossing time of the galaxy is longer than the entire age of humanity. That fact lands quietly at first, then becomes stranger the longer you sit with it. Human beings have gone from stone tools to space telescopes in less time than light needs to cross this one spiral galaxy. And NGC 6872 is still only one galaxy. A large one, yes, a record-setting one by the measurement that made it famous, but still one island of stars among the vast population of galaxies scattered through the observable universe. Now imagine beginning that light-speed crossing near the northeast arm, where observations revealed especially active regions of young stars. This arm was strongly affected by the gravitational encounter with IC 4970, and astronomers using ultraviolet and infrared data found that star formation increases along the spiral arms away from the older central region. NASA's description of the galaxy notes that the visible structure was revealed using combined ultraviolet, infrared, and visible light observations, which helped show the extended arms and young star-forming regions. From inside such an arm, the galaxy would not appear the way it does in telescope images. You would not see a neat spiral from within it. That is another slightly disappointing but important truth. We cannot look at the Milky Way from outside, which is why maps of our galaxy are reconstructions rather than ordinary photographs. Living inside a galaxy is like living inside a forest and trying to draw the shape of the whole woodland by measuring trunks around you. From within NGC 6872, you would see stars in every direction, some bright, some dim, many hidden by dust, many too faint to notice without instruments. You might see glowing nebulae if you were near regions of active star formation. You might see dense blue clusters of young stars shining intensely through the surrounding gas. In darker directions, you might see the broader glow of the galaxy's disk stretched across the sky. But the grand spiral shape would remain invisible from the inside. You would need distance to see the pattern. That is true of many things, not just galaxies. Up close, life can feel like scattered events. From farther away, a structure begins to appear. Astronomy quietly teaches that perspective changes meaning. As your imaginary journey continues inward, the environment changes gradually. The outer arm becomes richer. Gas clouds become more common. Star-forming regions appear where gravity has compressed cold hydrogen into dense knots. These places are not quiet in any ordinary sense. Young massive stars pour radiation into their surroundings. Stellar winds carve cavities into gas clouds. Supernova explosions scatter heavier elements across interstellar space. Yet from light's point of view, if light had a point of view, all of this simply passes. A photon does not experience time in the way we do. According to relativity, along the path of light itself, the usual idea of elapsed time becomes deeply strange. For us, watching from outside, that photon needs 522,000 years to cross NGC 6872. For the photon, speaking very loosely, the journey has no proper time. This is one of those facts that sounds like physics has had too much coffee. But it reminds us that time and distance are not as simple as everyday experience suggests. The universe is not merely large. It is large in ways that bend the ordinary meanings of travel, motion, and duration. For human beings, though, the crossing time remains the important part, more than 500,000 years. That means any view across NGC 6872 is always delayed by its own size. If you were somehow sitting near one edge and looking toward the opposite edge, you would see that far side as it was hundreds of thousands of years ago. The galaxy would contain internal time differences simply because light needs time to travel through it. Even a single galaxy is too large to be seen all at once in the same moment. That is a quietly astonishing thought. When we look at a person across a room, the delay is far too tiny to matter. When we look at the moon, we see it as it was just over 1 second ago. The sun appears as it was about 8 minutes ago. Across a giant galaxy like NGC 6872, the delay from one side to another becomes longer than recorded human history many times over. So if a supernova exploded in one arm, observers in the opposite arm would not know for hundreds of thousands of years. A civilization on one side could look across the galaxy and see ancient light from the other side, not present reality. Even neighbours within the same galaxy can be separated by deep time. This is one reason the phrase now becomes slippery in astronomy. On Earth, now feels simple because our environment is small and signals travel quickly. But across cosmic distances, now fractures into many delayed views. The universe does not present itself instantly. It arrives by messenger, and the messenger is light. NGC 6872, simply by being so large, turns that idea into something almost tangible. A galaxy wide enough that its own far edge belongs to the past of its near edge. Continuing through this imagined crossing, you eventually approach the central regions. Here the galaxy becomes more crowded. Stars are older on average. The bright blue star factories of the outer arms give way to more mature populations. The central bar stretches across the core, guiding gas and stars through elongated orbits. Barred spiral galaxies are particularly interesting because the bar can help move material inward toward the galactic center. Gas driven along the bar may feed central star formation, or in some cases contribute material toward an active galactic nucleus. In NGC 6872, the central region and bar show older stars and lower rates of star formation than parts of the outer arms, according to studies using ultraviolet and mid-infrared observations. That contrast matters. It means the galaxy is not forming stars uniformly everywhere. Its outer arms, stretched by interaction, are comparatively lively. The central region is more settled, older, less actively producing new stars. A crossing from edge to edge would therefore be a journey through different eras of stellar life. In the outer arms, young, bright stars. Near the centre, older populations. Farther outward again, more stretched regions shaped by tidal forces. A single galaxy becomes a timeline arranged in space. And somewhere near the heart of the system, as in many large galaxies, there is likely a supermassive black hole. Not a monster roaming through space swallowing stars like a hungry vacuum cleaner, despite what dramatic animations sometimes suggest. More like an extremely dense gravitational centre influencing nearby matter while remaining invisible unless actively feeding. Black holes are powerful, certainly, but space is wide and galaxies are vast. Even a central black hole is tiny compared with the full scale of a galaxy like NGC 6872. That is another useful reminder. The largest things in the universe are often not the densest things, and the densest things are often not visually large. A black hole may dominate imagination, but a spiral arm containing billions of stars can stretch across distances no black hole could visually occupy. Different kinds of enormity coexist. As the journey continues past the centre, the galaxy opens outward again. The opposite arm begins unfolding ahead, though ahead at light speed is a strange idea. More star-forming regions appear. Dust lanes thread through the disk. Gas clouds drift in enormous arcs. The gravitational memory of IC 4970's encounter remains written into the structure itself. This is perhaps the most Important thing to understand about crossing NGC 6872. You would not be crossing something still and simple. You would be crossing a record of events. Every region has history. The stretched arms remember tidal forces. The young stars remember compressed gas clouds. The older central populations remember earlier stages of galactic growth. The dark matter halo, invisible but essential, shapes the whole system from beyond the visible edge. A galaxy is not just a place. It is a history still happening. And the scale of NGC 6872 makes that history unusually large. By the time your imaginary beam of light finally reaches the far side, more than 522,000 years after departure as measured by outside observers, everything behind it has changed. Stars have moved along their orbits. Massive stars born near the beginning of the journey may already have died. Supernova remnants may have expanded into surrounding gas. New stars may have ignited in clouds that were still collapsing when the crossing began. The galaxy you leave is not the same galaxy you entered. Not because it transformed suddenly, but because 500,000 years is still time enough for change even inside an object that evolves slowly. And yet, by galactic standards, 522,000 years is not very long. That is the final little trick here. For us, 500,000 years feels enormous. For a galaxy, it is a brief interval, less than a blink compared with the billions of years over which NGC 6872 formed, grew, interacted and stretched into its present shape. So the crossing time is both unbelievably long and cosmically short. Astronomy does that often. It gives you a number, then changes the scale, till the number becomes both huge and tiny, depending on where you stand. To a human life, NGC 6872 is impossibly wide. To the age of the universe, light crosses it in a small fraction of cosmic history. To a photon, the journey is stranger still. That layered perspective is part of what makes the galaxy so fascinating. It does not merely exceed ordinary size, it forces ordinary measurements to feel unstable. Years, distances, motion, even now, all become less simple when stretched across 500,000 light-years of stars, and maybe that is why imagining a crossing through NGC 6872 feels different from simply reading its diameter. A number tells you the galaxy is large. A crossing helps you feel how large. It lets you picture one edge falling into the deep past of the other. It lets you imagine civilizations separated not only by distance, but by the time their light needs to arrive. It turns the galaxy from a distant object into an enormous landscape of delayed signals, slow motion, and hidden histories. Somewhere in that vastness, stars are forming now, though the light of that now will not reach anyone across the galaxy for hundreds of thousands of years. Somewhere else, old stars are cooling, gas is drifting, dust is gathering, gravity is quietly adjusting the paths of everything it touches. And far outside the galaxy, from the perspective of Earth, all of that arrives to us as ancient light from 212 million years ago. So we are delayed twice over. We see NGC 6872 as it was when its light left the galaxy long before humans existed. And within that ancient image, one side of the galaxy is also seeing the other side through its own internal delay. The universe is layered with old messages crossing in every direction. That thought can be surprisingly restful. Nothing in deep space is demanding immediate understanding. No galaxy asks to be solved quickly. NGC 6872 simply turns through darkness, wide enough that light itself must take its time, while gravity continues shaping the long spiral arms and star factories along its edges. And once we have spent a little while imagining that impossible crossing, the next question begins to form naturally. If a galaxy can be this large, and if its arms can stretch so far while still making new stars, then what exactly is hidden inside all that space? All those arms, all those star fields, and all those generations of suns quietly filling the giant with light. Inside NGC 6872, there are stars no human being will ever see individually. That may sound obvious at first. Of course there are. The galaxy is more than 200 million light-years away. Even our best telescopes cannot isolate every single star across a structure that enormous. But if you sit with the idea for a moment, it becomes strangely unsettling in a quiet sort of way. Entire suns hidden forever inside one galaxy. Not a few, not thousands, billions upon billions of them. Every point of light blended into the galaxy's glow represents another star system, another gravitational center, another place where planets may orbit in darkness around distant suns. Some stars are young and blue, others are ancient and red. Some may host giant gas planets larger than Jupiter. Some may have rocky worlds with frozen oceans. Somewhere inside those enormous spiral arms there are almost certainly planets where the night sky looks unlike anything imaginable from Earth. And yet from our perspective, most of it merges into one distant shape, a faint giant in the dark. Astronomy often works this way. The farther away something becomes, the more complexity compresses into simplicity. A galaxy that actually contains staggering detail appears at first glance like a quiet smudge of light. Only gradually, through larger telescopes and longer observations, does the hidden structure emerge. An NGC 6872 contains an astonishing amount of hidden structure. Scientists do not know the exact number of stars inside the galaxy, because counting individual stars directly across such distances is impossible with current technology. Instead, astronomers estimate stellar populations by measuring brightness, mass, and galactic dynamics. The total likely reaches into the hundreds of billions of stars, possibly comparable to or greater than the stellar population of the Milky Way itself, depending on how the galaxy's enormous extended structure is measured. Which means this giant spiral may contain enough stars to support unimaginable numbers of planetary systems. That thought alone changes the galaxy slightly. It stops feeling like a distant object and begins feeling more like a cosmic continent. And stars themselves are wonderfully diverse things. People often picture stars as identical glowing dots, because from Earth, most stars appear roughly similar to the naked eye. But stars differ enormously in size, temperature, colour, lifespan, brightness, and behaviour. Some are tiny red dwarfs so dim and cool that they can burn quietly for trillions of years, far longer than the current age of the universe. Others are massive blue giants that shine ferociously and die after only a few million years. Some stars pulse rhythmically, some erupt violently, some orbit companions in binary systems, some drift alone through space, some collapse into white dwarfs, others explode into neutron stars or black holes. A galaxy is not merely a collection of stars. It is a collection of stellar lives unfolding simultaneously across different stages of cosmic time. And inside NGC 6872, all those stellar populations spread across a structure so large that the galaxy almost becomes a universe of its own. The outer spiral arms especially contain large populations of young stars. Astronomers identified intense star-forming regions along those elongated tidal structures where gravitational interactions compressed gas clouds enough to trigger stellar birth. These young stars shine bright blue-white because they are hot, energetic, and relatively short-lived. Blue stars are the loud extroverts of astronomy. They arrive dramatically, shine brilliantly, and leave early. Our Sun is much calmer. A yellow dwarf star like the Sun burns steadily for billions of years with very little drama most of the time. That kind of stability turns out to be rather useful for planets trying to develop complicated chemistry and eventually slightly anxious intelligent organisms. Inside NGC 6872, though, many regions are far more energetic than our local stellar neighbourhood. Massive stars flood surrounding space with ultraviolet radiation. Stellar winds push gas outward through interstellar clouds. Supernova explosions enrich nearby regions with heavier elements. Entire clusters of stars emerge together from collapsing molecular clouds, and because the galaxy is so large, these processes occur simultaneously across enormous distances. One spiral arm may contain newborn star clusters, while another region holds ancient red stars nearing the quiet ends of their lives. Different eras coexist. That is one of the most beautiful things about galaxies. They preserve history, spatially. By looking at different stellar populations, astronomers can reconstruct pieces of a galaxy's past. Young stars reveal recent star formation. Older stars trace ancient structure. Chemical composition exposes previous generations of supernova explosions. Galaxies, remember, not consciously of course, but physically. Every star contains clues about the environment that formed it. For example, the earliest stars in the universe contained almost no heavy elements, because those elements had not yet been created in large quantities. Later generations inherited richer material forged by previous stars. So when astronomers examine stellar chemistry, they effectively study cosmic ancestry. Some stars inside NGC 6872 likely formed billions of years ago when the galaxy itself looked very different. Others formed much later during interactions with neighbouring systems like IC 4970. The galaxy's current appearance is really the result of many different stellar generations layered together over time, and somewhere near the centre, stars crowd more densely than they do in the outer arms. Galactic centres are strange environments. In our own Milky Way, stars near the centre orbit through regions packed far more tightly than the relatively calm suburbs where the solar system resides. NGC 6872 almost certainly behaves similarly. Near its central bar and core, stellar densities increase. Gravitational interactions become more intense. Gas dynamics grow more complicated, and somewhere deep within that crowded central region likely sits a supermassive black hole. Almost every large galaxy studied carefully appears to host one. That realization still feels wonderfully absurd. Human beings spent most of history unaware that galaxies even existed. Then we discovered galaxies. Then we discovered many galaxies contain gigantic black holes at their centers. The universe enjoys escalating things unexpectedly. Supermassive black holes themselves remain difficult to visualize emotionally, because they combine huge mass with surprisingly compact size. A black hole millions or billions of times more massive than the Sun may still occupy a region smaller than the solar system. Compared to the full size of NGC 6872, even a giant black hole remains tiny. The galaxy stretches across over 500,000 light-years. The central black hole, enormous though it may be, occupies only a minute fraction of that structure. Scale changes everything again. And scale inside galaxies produces another interesting effect. Communication becomes almost meaningless across large distances. Imagine civilizations existing on opposite ends of NGC 6872. Even travelling at light speed, messages would require over 500,000 years to cross the galaxy. Conversations become impossible. Entire civilizations could rise and disappear before replies arrived. A galaxy that large is not a unified neighbourhood in any practical sense. It is more like an enormous archipelago separated by time itself. Of course, whether intelligent life exists anywhere inside NGC 6872 remains completely unknown. We have no evidence of extraterrestrial civilizations there or anywhere else yet. But astronomers increasingly suspect planets themselves are extraordinarily common throughout the cosmos. The Kepler Space Telescope revealed that planetary systems are normal rather than rare. Most stars likely host planets. Some stars host many, which means galaxies probably contain staggering numbers of worlds. The Milky Way alone may contain hundreds of billions of planets. Now apply that idea to a galaxy even larger and more extended than our own. Suddenly, NGC 6872 stops feeling empty despite all the vast distances involved. It becomes crowded with possibility. And yet, Despite the unimaginable number of stars inside giant galaxies, individual stellar systems remain astonishingly isolated from one another. Space between stars is so large that even light needs years to travel between neighbouring systems. That isolation shapes galactic life profoundly. Stars evolve mostly alone. Planetary systems form independently. Supernova explosions may influence nearby regions, but direct stellar collisions remain extremely rare except in very dense environments like globular clusters or galactic cores. Galaxies are social structures built from isolated members, a little like cities viewed from airplanes at night perhaps. From far away, everything blends into one glowing structure. Up close, individuals remain separated by enormous emotional and physical distances, though admittedly stars rarely complain about traffic. One particularly fascinating aspect of stellar populations inside NGC 6872 involves the outer tidal arms. These regions likely contain younger average stellar ages because gravitational interactions triggered fresh waves of star formation there. Astronomers observing ultraviolet light detected active stellar nurseries spread through the stretched structures, so the galaxy's most dramatic-looking regions are also among its youngest in stellar terms. That feels fitting somehow. The parts most visibly shaped by gravitational disturbance became places where new stars emerged. Meanwhile, older populations dominate calmer central regions where star formation slowed somewhat over time. Again, the galaxy behaves almost like a timeline written spatially, and stars themselves influence galactic evolution continuously. Massive stars enrich surrounding gas with heavier elements through stellar winds and supernova explosions. Those heavier elements become ingredients for future planets, moons, asteroids, atmospheres, and potentially biology. Without earlier generations of stars, life as we know it could not exist. Hydrogen alone is not enough. The carbon in your body, the oxygen you breathe, the calcium in your bones, the iron in your blood, all originated inside stars that lived and died long before Earth formed. In that sense, galaxies are not just collections of stars, they are chemical engines, factories producing complexity over cosmic timescales, and giant spiral galaxies like NGC 6872 perform this process on enormous scales for billions of years continuously. Some stars inside the galaxy already died before Earth even formed. Their material dispersed into interstellar space, joined new molecular clouds, and helped create later generations of stars. That recycling process continues even now. Galaxies evolve chemically as well as structurally. The longer a galaxy forms stars, the richer its interstellar medium becomes in heavier elements. Young galaxies early in cosmic history contained fewer complex elements than mature galaxies today, which means the universe itself gradually became more chemically interesting over time. The cosmos spent billions of years slowly learning complexity. And somewhere inside NGC 6872's immense stellar population, stars continue contributing to that process right now. Massive stars burn rapidly toward explosive endings. Smaller stars glow steadily for billions of years. White dwarfs cool slowly. Binary systems exchange matter dramatically. Every stellar life unfolds independently, while simultaneously contributing to the galaxy as a whole. Perhaps that is another reason galaxies feel strangely comforting. They contain both individuality and structure together. Each star follows its own path, yet together they form larger patterns visible across impossible distances. For something as enormous as NGC 6872 to exist at all, a remarkable number of things had to go right over billions of years. Or perhaps right is not the correct word. Galaxies do not have goals exactly. They are not trying to become giant spirals any more than storms are trying to become hurricanes. Still, the conditions required for a spiral galaxy to grow this large, while preserving recognizable structure, are unusual enough that astronomers pay close attention whenever they find one. Because most galaxies never become this enormous. and many of the ones that do grow very large stop being spiral galaxies long before reaching such scales. That is one of the central mysteries surrounding NGC 6872. The galaxy did not merely become huge, it somehow stayed spiral while doing so. Those are two separate achievements. To understand why that matters, it helps to remember something slightly surprising. The universe is filled mostly with small galaxies. People tend to imagine giant galaxies because giant things attract attention. The Milky Way, Andromeda Galaxy, massive ellipticals sitting at the centres of galaxy clusters like ancient cosmic kings. But statistically speaking, dwarf galaxies dominate the population. Tiny galaxies, faint galaxies, galaxies containing only a few billion stars or less. Compared to giants like NGC 6872, many dwarf galaxies look almost fragile. Some contain irregular shapes without clear structure. Others orbit larger galaxies as satellites, slowly being stripped apart by tidal forces. A few are little more than loose collections of stars and dark matter drifting through space quietly. The Milky Way itself is surrounded by many dwarf companions even now, and over cosmic time large galaxies often consume smaller ones. Gravity again. Always gravity. The universe builds larger structures gradually by merging smaller ones together, but that process is messy. Violent in slow motion perhaps, but still messy. Every collision changes galactic structure. Every merger redistributes stars, gas, and angular momentum. And spiral galaxies are especially vulnerable during these encounters. That vulnerability explains why many of the largest galaxies in the universe are not spirals at all. Instead, they are giant elliptical galaxies. Ellipticals look very different from systems like NGC 6872. They lack elegant spiral arms. Their stars move along more randomized orbits. Many contain older stellar populations and relatively little ongoing star formation. Some grow enormous through repeated mergers until they become sprawling elliptical giants dominating galaxy clusters. In dense regions of the universe, this tends to happen frequently. Galaxies interact, they merge, spiral structure becomes scrambled, ellipticals emerge. So in a sense, giant spiral galaxies occupy a difficult middle ground. They must grow large enough to accumulate enormous mass while somehow avoiding the kinds of catastrophic interactions that would erase their spiral identity completely. That balancing act is rare. Astronomers think NGC 6872 managed it partly because of environment. Environment matters enormously in galactic evolution. Galaxies living in crowded clusters experience constant gravitational interactions. Neighbouring systems pull on them continuously. Gas can be stripped away by hot intergalactic plasma. Repeated mergers disturb structure over time. Life inside galaxy clusters is not calm. Meanwhile, galaxies in more isolated regions may preserve spiral structure longer because fewer violent encounters occur. But complete isolation creates a different problem. Without mergers or inflows of fresh gas, galaxies may struggle to grow extremely large. NGC 6872 appears to occupy a fascinating compromise. It experienced enough interaction to stimulate growth and reshape its structure dramatically, but not enough to destroy the spiral pattern entirely. At least not yet. That yet matters because galaxies continue evolving. Nothing guarantees NGC 6872 will remain spiral forever. Given enough time and enough interactions, even giant spirals may eventually transform into something else. The universe changes everything eventually. Still, surviving this long as a spiral at such scale already makes the galaxy unusual. And the farther astronomers looked into galactic populations overall, the more they realized another factor strongly limits spiral growth: gas supply. Galaxies need gas to make stars. Without large reservoirs of hydrogen and other material, star formation slows gradually until galaxies become dominated by older stellar populations. spirals especially depend on active star formation, because young bright stars illuminate spiral arms visibly. No gas means no fresh stars. No fresh stars means spiral structure fades over time. Many giant galaxies run into this problem eventually. Either they consume their gas too quickly, or environmental effects strip it away. In large galaxy clusters, hot surrounding gas can prevent galaxies from cooling and forming new stars efficiently. Astronomers sometimes describe this as galactic starvation, which sounds surprisingly emotional for astrophysics. But the concept fits. A galaxy deprived of fresh gas gradually quiets down. Star formation declines. Young blue stars disappear first because they burn out quickly. Older redder stars dominate increasingly. The galaxy ages visibly. NGC 6872 avoided complete quenching somehow. Its enormous spiral arms still contain active star-forming regions. Large reservoirs of gas remain spread through the system, especially in those elongated tidal structures created by interaction with IC 4970. So while many giant galaxies became quiet ellipticals, NGC 6872 remained active enough to preserve visible spiral character. Again, balance. Too little interaction, and perhaps the galaxy never grew so large. Too much interaction and spiral structure vanishes. Too little gas and star formation dies. Too much violent star formation and internal dynamics shift dramatically. Galaxies evolve through compromises written by gravity over billions of years. Another reason most spirals remain smaller involves angular momentum. Galactic disks rely on organized rotation. Stars orbit coherently around galactic centers. Spiral structure emerges partly from that rotational order. But mergers disrupt angular momentum significantly. Imagine stirring cream into coffee. At first, clear structures remain visible, but continued disturbance gradually scrambles organized patterns into turbulence. Galaxies behave similarly. Repeated major mergers randomize stellar orbits and destroy thin rotating disks. The more chaotic the merger history becomes, the harder it is for spiral structure to survive. That is why giant elliptical galaxies often contain stars moving in many different directions rather than neatly rotating inside disks. NGC 6872 somehow maintained enough rotational organization to preserve its spiral identity despite becoming enormous, which is not impossible, just uncommon. And then there is dark matter. Invisible, mysterious, unavoidable dark matter. Modern astronomy suggests galaxies sit inside huge halos of dark matter extending far beyond visible stars. These halos influence galactic growth profoundly. They shape how galaxies rotate, how they merge, how gas accumulates, and how structure evolves over time. The size and stability of NGC 6872 likely depend heavily on its dark matter halo. Without sufficient dark matter, the galaxy's outer regions might not remain gravitationally bound at all. The elongated spiral arms especially require stabilization across enormous distances. And here, astronomy becomes slightly unsettling again because scientists still do not know exactly what dark matter is. We infer its existence through gravity. We observe its effects everywhere, but the substance itself remains invisible, which means one of the largest spiral galaxies in the universe may owe much of its survival to material nobody has ever directly detected. The cosmos continues behaving like a place designed specifically to keep physicists awake at night. Of course, giant size alone does not automatically make a galaxy more interesting scientifically. Some galaxies become large simply through repeated accumulation over time. But NGC 6872 matters because it combines scale with preserved structure. It challenges expectations. Astronomers use galaxies like this to test models of galactic evolution. Computer simulations attempt to reproduce how giant spirals form and survive. Researchers vary merger histories, dark matter distributions, gas dynamics, and interaction angles, trying to understand which conditions allow systems like NGC 6872 to exist. And simulations reveal something important. Galactic evolution is deeply sensitive to history. Small differences early on can produce dramatically different outcomes later. A slightly different collision angle billions of years ago might have transformed NGC 6872 into an elliptical galaxy instead. A different gas supply could have quenched star formation earlier. A denser environment might have stripped away outer arms entirely. Galaxies are shaped not only by universal laws but by individual histories. That idea feels strangely personal somehow. The universe itself contains contingency. Outcomes are not predetermined in simple ways. Tiny variations accumulate over immense spans of time until giant differences emerge. And because galactic evolution unfolds so slowly, every surviving structure becomes a kind of historical document. NGC 6872's stretched arms preserve evidence of tidal interaction. Its stellar populations preserve records of star formation history. Its rotation preserves angular momentum from ancient events. Its continued spiral structure preserves the fact that certain catastrophic mergers never fully occurred. The galaxy is not just large, it is specific, a particular outcome among countless possible galactic histories, and perhaps that is one reason giant spiral galaxies feel emotionally different from giant ellipticals. Spirals appear dynamic and alive with ongoing structure. Their arms contain visible motion, active star formation, and organized patterns. Ellipticals often feel calmer but older, more settled, a little like ancient cities compared to sprawling younger coastlines. Not better or worse, just different evolutionary stages. NGC 6872 still belongs firmly to the spiral category despite its unusual dimensions. The galaxy continues forming stars, its arms remain visible. Rotation still organizes the structure coherently, though gravity is clearly testing those limits continuously. One especially interesting possibility is that giant spiral galaxies may represent transitional systems in some cases. Given enough additional interactions, systems like NGC 6872 could eventually evolve toward more elliptical forms. We may be observing not a permanent galactic type, but a temporary phase. Temporary, of course, meaning billions of years. Astronomy uses the word temporary rather generously sometimes. Still, the galaxy's current appearance offers a rare glimpse into what happens when spiral structure stretches nearly to the edge of stability. The arms extend so far that they almost appear detached in places. Star-forming regions continue operating across huge distances. Gravitational interactions remain visible directly in the structure itself. It is a galaxy operating near the limits of what spiral systems seem capable of maintaining. And perhaps that is why people find objects like NGC 6872 so compelling even outside professional astronomy. They reveal the universe not as neat and uniform, but as varied, experimental, and full of strange exceptions. Nature does not stop at good enough. Sometimes gravity builds something excessive simply because the conditions allowed it. A spiral galaxy 5 times wider than the Milky Way. Arms stretched across 500,000 light-years. Billions of stars still forming new generations despite enormous age and tidal distortion. A giant balanced delicately between order and disruption. If you removed all the visible stars from NGC 6872, the galaxy would still weigh far too much. That realization changed astronomy forever. At first, scientists assumed galaxies were mostly what they appeared to be. Collections of stars, gas, dust, perhaps a black hole at the center, all held together by ordinary gravity. Simple enough in principle. Measure the visible matter. Calculate the gravitational pull, and the motions of stars should make sense. Except they did not. Stars near the outer regions of galaxies moved much faster than expected. Far too fast. According to ordinary calculations using visible matter alone, many galaxies should not remain stable at all. Their outer stars should drift away into space because the gravitational pull from visible stars was not strong enough to hold everything together. And yet galaxies stubbornly refused to fly apart, which meant one of two things had to be true. Either gravity itself behaved differently across galactic scales, or most of the mass inside galaxies was invisible. Astronomers eventually leaned toward the second explanation: dark matter. Even the name feels slightly unfinished, as though scientists discovered something enormous and mysterious and decided to label it quickly before lunch. But despite the simple name, dark matter remains one of the strangest discoveries in modern science. Nobody has directly observed it. No telescope sees it glowing. It does not emit light, reflect light, or absorb light in ordinary ways, and yet its gravitational effects appear everywhere. Galaxies rotate too quickly without it. Galaxy clusters contain too much mass without it. Gravitational lensing bends light more strongly than visible matter alone can explain. The large-scale structure of the universe itself seems shaped by dark matter, invisible gravity scaffolding spread across the cosmos, and giant galaxies like NGC 6872 almost certainly depend on it enormously. Because when astronomers study the galaxy's extraordinary size, especially those stretched spiral arms extending across more than 500,000 light-years, one question immediately appears. How does all of this remain gravitationally bound? Visible matter alone likely is not enough. The outer arms especially present a challenge. Stars and gas orbiting far from the centre move under the influence of gravity spread across enormous distances. Without additional unseen mass, those outer structures might disperse gradually instead of remaining coherent, but they do remain coherent, which strongly suggests NGC 6872 sits inside a huge dark matter halo extending far beyond the visible galaxy itself. This is one of the strangest things about galaxies once you understand it properly. The part we see may only be a small fraction of the whole structure. Imagine looking at a city at night from an airplane. You see glowing windows, streetlights, headlights, illuminated buildings. Now imagine discovering that all the visible light represented only a tiny fraction of the city's actual mass and structure. That is roughly the situation astronomers face with galaxies. The stars are the glowing, visible layer. The dark matter halo is the hidden framework surrounding everything, and the halo may extend vastly farther than the luminous spiral arms themselves. In the case of NGC 6872, this invisible structure likely plays several critical roles simultaneously. First, it helps stabilize the galaxy gravitationally. Second, it influences how the galaxy interacts with neighboring systems like IC 4970. Third, it shapes the rotational dynamics across the entire disk. And finally, it probably affected the galaxy's growth history over billions of years, all while remaining completely invisible. Astronomy occasionally feels like trying to understand an enormous machine while being unable to see most of the machinery. Dark matter halos themselves are difficult to picture because they are not solid shells surrounding galaxies neatly. Instead, astronomers think they form vast diffuse structures made from particles still unknown to physics. These halos contain far more mass than visible stars and gas combined in many cases. In the Milky Way, for example, dark matter may outweigh ordinary visible matter by roughly 5-1, which means most of our galaxy is invisible. That fact remains quietly astonishing no matter how many times you hear it. Human beings evolved under skies filled with visible stars and naturally assumed visible things dominated reality. Then astronomy gradually revealed that ordinary matter, the stuff making planets, stars, oceans, mountains, trees, coffee cups, and sleepy listeners late at night, may represent only a small fraction of the universe's total mass energy content. Most of the cosmos is hidden from direct view, a slightly dramatic discovery for a species already nervous about losing car keys. Still, dark matter is not merely theoretical imagination. The evidence supporting it became overwhelming over time. One of the earliest major clues came from galaxy rotation curves. Normally, objects farther from a central mass orbit more slowly. The planets in the solar system behave this way. Mercury moves quickly because it sits close to the Sun. Neptune moves more slowly because it orbits much farther away. Galaxies should behave similarly. Stars near galactic centers should orbit rapidly, while outer stars slow down with increasing distance. But observations showed something unexpected. Outer stars kept moving fast. Very fast. The rotation curves flattened instead of declining. It was as though galaxies contained enormous amounts of hidden mass spread far beyond visible stars. And giant galaxies like NGC 6872 magnify this mystery beautifully because their visible structure extends across such huge distances. The elongated spiral arms continue orbiting coherently despite being far from the central regions where most visible mass concentrates. Something additional must be helping hold the system together. Dark matter provides the best current explanation. Though admittedly best explanation in astronomy often translates loosely to the thing least likely to collapse entirely under observation, scientists still do not know what dark matter particles actually are. Several candidates exist: weakly interacting massive particles, axions, other exotic possibilities. Experiments around the world continue searching for direct evidence. So far, nothing definitive, which means galaxies like NGC 6872 remain partly governed by something humanity has not yet fully identified. There is something wonderfully humbling about that. We can map giant galaxies hundreds of millions of light years away. We can measure star formation rates and rotational dynamics across enormous distances. We can simulate galactic collisions on supercomputers, yet we still cannot directly explain most of the matter shaping those systems. The universe continues keeping secrets, and dark matter halos do more than simply stabilize galaxies individually. They also shaped how galaxies formed in the first place. In the early universe, ordinary matter alone may not have clumped together quickly enough to build large-scale structure efficiently. Dark matter, however, interacts strongly through gravity, while apparently ignoring electromagnetic forces. That means it could begin forming gravitational scaffolding earlier. Ordinary gas then fell into those dark matter wells gradually, forming stars and galaxies over time. In a sense, galaxies may have grown inside invisible frameworks already prepared for them, which gives giant spirals like NGC 6872 an even stranger dimension. The visible galaxy might represent only the luminous decoration inside a much larger unseen structure. The stars are not the foundation. They are the glow outlining the foundation, and the halo surrounding NGC 6872 is probably enormous. Much larger than the visible disk. Far beyond the stretched spiral arms likely extends a diffuse cloud of dark matter, influencing the motions of stars, gas, and neighbouring galaxies continuously. This hidden halo may also explain part of why the galaxy survived gravitational interactions without completely falling apart. When NGC 6872 interacted with IC 4970, the dark matter halos of both systems probably interacted too. Not through collisions exactly. Dark matter appears to pass through ordinary matter and itself relatively easily because it barely interacts except gravitationally. But gravitational effects still matter enormously. The halos influenced orbital paths, energy distribution, and tidal distortions during the encounter. Without those halos, the visible galaxies may have behaved differently entirely. Again, invisible structure shaping visible outcomes. Astronomy returns to this pattern repeatedly. What we see often depends on what we cannot see. Even ordinary galaxies contain hidden layers beyond dark matter alone. Interstellar gas spreads through galactic disks. Hot plasma fills halos. Magnetic fields thread through space invisibly. Cosmic rays move through interstellar environments constantly. the visible stars represent only part of the story, but dark matter dominates the hidden mass budget so strongly that it changes how astronomers think about the universe altogether. For centuries, people assumed stars were the primary actors in galactic dynamics. Now stars appear more like luminous passengers riding inside larger invisible gravitational systems, which can feel slightly unsettling the first time you realize it. Our entire visible galaxy drifting inside an unseen halo stretching far into darkness, and NGC 6872 especially highlights this idea because its outer arms push visible structure close to the limits of what ordinary matter alone could plausibly support. The galaxy almost acts like a demonstration of dark matter's importance. Without the halo, the giant spiral might not exist in recognizable form at all. Of course, not every scientist agrees completely on every detail. Some alternative theories attempt modifying gravity itself rather than invoking dark matter particles. These ideas explore whether gravity behaves differently at very large scales. So far, however, dark matter remains the dominant explanation because it successfully accounts for many independent observations simultaneously. Galaxy rotation, cluster dynamics, gravitational lensing, large-scale cosmic structure, the cosmic microwave background, all point towards substantial unseen matter shaping the universe. And perhaps the strangest part is that dark matter may actually outnumber ordinary matter significantly throughout the cosmos. The stars we admire in telescope images, the planets we stand on, the atoms making life possible, all of it may represent only a minority component of reality. Visible matter is the exception rather than the rule. That thought changes galaxies emotionally somehow. NGC 6872 already feels enormous when viewed as a visible spiral galaxy. But once you imagine the hidden halo surrounding it, extending outward invisibly across even larger distances, the system becomes stranger and more majestic at the same time. A glowing spiral suspended inside an unseen gravitational ocean, and dark matter halos themselves do not stop neatly at galactic boundaries either. They overlap, interact, and connect galaxies within larger structures across space. The universe resembles a cosmic web partly shaped by dark matter distributions stretching across unimaginable scales. Galaxies gather where invisible matter gathered first, everything built upon hidden architecture. Perhaps that idea feels oddly familiar in another sense too. Human beings often notice visible outcomes long before understanding underlying causes properly. We see waves without immediately understanding tides. We see weather before understanding atmospheric dynamics. We see galaxies before realizing invisible matter dominates them. Reality keeps depth hidden initially. Science slowly uncovers additional layers, and giant galaxies like NGC 6872 remind us how much remains beneath the surface even now. Because despite everything astronomers have learned about this enormous spiral system, huge questions remain unresolved. What exactly is dark matter? How did halos shape the earliest galaxies? Why do some spiral galaxies survive interactions while others lose structure entirely? How large can spiral systems truly become before gravity transforms them into something else? NGC 6872 sits near those questions quietly, rotating through darkness while its invisible halo continues holding billions of stars together across 500,000 light-years of space. Yet at first glance, IC 4970 does not look particularly intimidating, which is rather funny considering it helped reshape one of the largest spiral galaxies in the known universe. Compared beside NGC 6872, the smaller companion almost seems modest. Astronomers classify IC 4970 as a lenticular galaxy, a type sitting somewhere between spiral and elliptical systems in appearance. Lenticular galaxies usually contain disk-like structures, but lack the dramatic active spiral arms found in galaxies like the Milky Way or NGC 6872. they often appear calmer, older perhaps, a little more reserved. If NGC 6872 resembles an enormous swirling cosmic coastline stretched across space, IC 4970 looks more like a compact neighbouring island drifting nearby quietly, and yet gravity does not care about appearances. It only cares about mass, distance and time. Given enough time, even a smaller galaxy can profoundly reshape a much larger companion through tidal interaction. That is exactly what happened here. IC 4970 likely passed close enough to NGC 6872 to disturb the giant spiral gravitationally, stretching its outer arms into the extraordinary elongated structures astronomers observe today. The process unfolded slowly across hundreds of millions of years, almost impossibly gentle from a human perspective, yet dramatic on galactic scales. And this interaction remains ongoing. That is important. When people hear collision, they often imagine something finished. A crash, a moment, a before and after. Galactic encounters rarely behave that way. Instead, galaxies influence each other gradually over immense spans of time. Their stars continue orbiting. Their gas clouds respond to changing gravitational fields. Their structures distort and evolve continuously. NGC 6872 and C4970 are still dancing, a very slow dance admittedly, one requiring several 100 million years per movement, but a dance nonetheless. Astronomers studying the pair discovered that the companion galaxy passed close enough to generate huge tidal forces across the giant spiral. Those forces stretched the outer regions outward, like soft fabric being gently pulled from one side. The resulting spiral arms became astonishingly long. Without IC 4970, NGC 6872 might still have been a large spiral galaxy, but likely not one famous for its extraordinary extended structure. The companion interaction amplified the system dramatically, which raises an interesting point about galaxies generally. Galaxies are social objects. Not social in the friendly sense, perhaps. Nobody sends birthday cards across intergalactic space, but galaxies rarely evolve completely alone. Gravity ensures that neighbouring systems influence one another continuously over cosmic timescales. The Milky Way itself experiences this right now. Several dwarf galaxies orbit our galaxy currently. Some are gradually being torn apart by tidal forces. Streams of stars from ancient mergers stretch across the Milky Way halo like faint rivers tracing forgotten interactions. Even the future collision between the Milky Way and Andromeda Galaxy has already begun gravitationally in a sense. The two galaxies move toward each other slowly, destined to merge billions of years from now. Galactic isolation is temporary at best, and IC 4970 demonstrates beautifully how even smaller companions can exert enormous influence if conditions align correctly. One reason the interaction became so dramatic involves orbital geometry. Not every galactic encounter produces spectacular tidal arms. The details matter enormously. Approach angle, relative velocity, distance of closest approach, galactic orientation, mass distribution, dark matter halos, gas content, all influence the outcome. Galaxies behave a bit like musical instruments in this respect. Slightly different conditions produce very different resonances. In the case of NGC 6872, the encounter happened in a way that amplified the spiral structure rather than destroying it completely. That balance again. Too violent and the galaxy may have lost its disk entirely. Too weak and little visible distortion would occur. Instead, the interaction stretched the arms dramatically, while preserving enough structure for the galaxy to remain recognizably spiral. Astronomers using computer simulations recreated likely versions of the encounter, and found that the companion's gravitational pull could indeed generate structures matching the observed elongated arms. Over time, tidal forces redistributed stars and gas across huge distances, and because gas responds strongly to compression, star formation increased in parts of those stretched arms afterward. IC4970 did not merely distort the galaxy, it helped trigger new stars inside it, again gravity acting simultaneously as sculptor and creator. The companion galaxy itself also changed during the interaction, of course. Galactic encounters rarely affect only one participant. Tidal forces operate both ways, though the visible consequences differ depending on mass and structure. IC4970 likely experienced its own gravitational disturbances, gas redistribution, and orbital evolution during the encounter. The galaxies influenced one another continuously while moving through surrounding dark matter, halos, and intergalactic space. The whole process resembles a conversation written in gravity rather than words. And because galaxies move slowly, the conversation unfolds over intervals so large they almost stop feeling like events. Human beings tend to divide experiences into moments, minutes, days, years perhaps. Galactic interactions ignore those scales entirely. Imagine watching continents drift. That still happens far faster than some galactic processes. One especially fascinating detail about IC4970 involves how ordinary it might have seemed before astronomers fully understood its role. Left alone, the galaxy probably would not attract enormous public attention. It lacks the huge, sweeping spiral arms of NGC 6872. It does not dominate its region dramatically, and yet without it, one of astronomy's most remarkable giant spirals might look entirely different. This happens throughout the universe constantly. Smaller companions shape larger systems. Tiny gravitational influences accumulate. Minor interactions become major structural changes over time. Scale in astronomy is rarely straightforward. A smaller galaxy can reshape a giant if given enough time and the correct orbital path. A tiny black hole can disrupt stars. Invisible dark matter can dominate galactic dynamics. Small fluctuations in the early universe can eventually grow into galaxy clusters spanning millions of light years. The cosmos builds complexity gradually from subtle beginnings, and IC4970 serves as a beautiful reminder that size alone does not determine influence. The interaction between these galaxies also reveals something important about spiral structure itself. Spiral galaxies are not rigid objects. Their arms can stretch, bend, compress, and reform under gravitational stress. NGC 6872's famous elongated arms are not fixed architectural features carved permanently into space. They are dynamic responses to interaction. That means the galaxy's current appearance represents only one stage in an ongoing evolutionary process. Billions of years earlier, the spiral likely looked different. Billions of years later, it may look different again. Galaxies are temporary forms. Long-lived temporary forms, certainly, but temporary nonetheless. Even giant spirals eventually change. Sometimes mergers produce elliptical galaxies. Sometimes interactions trigger bursts of star formation, followed by quieter periods. Sometimes gas reservoirs deplete gradually until galaxies fade into older, redder systems. Nothing remains fixed forever. And IC4970 may ultimately contribute to further transformation of NGC 6872 over immense future timescales. Of course, when astronomers describe galactic interactions calmly, it becomes easy to forget the absurd scales involved. The gravitational forces reshaping NGC 6872 operate across hundreds of thousands of light years. Entire star systems move because of these interactions. Gas clouds larger than smaller galaxies become compressed and stretched. Dark matter halos overlap and influence orbital dynamics invisibly. The amount of mass involved is staggering. Yet because everything happens gradually, the galaxies appear graceful rather than violent. This is one of astronomy's great illusions. Slow motion often looks peaceful, even when enormous energies are involved. A hurricane viewed from orbit can appear beautiful despite its destructive power. A galaxy collision viewed over millions of years can look elegant despite reshaping billions of stars. and perhaps elegance itself is partly a matter of timescale. IC4970's pull on NGC 6872 continues writing structure into the larger galaxy even now. Stars inside the spiral arms orbit along paths influenced by past encounters. Gas clouds collapse where tidal compression increased density. Young stars illuminate regions disturbed by gravitational stress. The interaction remains visible directly in the galaxy's anatomy, which means astronomers are reading NGC 6872, are also reading the history of its companion relationship simultaneously. Galaxies preserve encounters physically. Streams of stars, tidal tails, warped disks, elongated arms, all become records of past interactions written across space. Some galaxies even contain faint stellar streams from companions completely absorbed long ago, ghost structures lingering after mergers. The universe has memory in that sense, not conscious memory, structural memory. And NGC 6872's stretched arms are among the clearest examples of tidal memory astronomers have observed in a giant spiral system. Another interesting feature involves timing. We see the interaction not as it exists now, but as it existed over 200 million years ago because of the time light needs to reach Earth. The galaxies themselves already changed further since the photons currently entering telescopes first began travelling toward us. The interaction continues beyond the image we see. In reality, the galaxies occupy states slightly ahead of our observations continuously. Astronomy always studies the past, even when observing ongoing processes. That creates a slightly haunting quality around distant galaxies. We never see them in the true present. We see ancient light carrying delayed information across intergalactic space, and the larger the structures involved, the stranger those delays become. Inside NGC 6872 itself, light requires over 500,000 years to cross from one edge to the other. So even within the galaxy, different regions observe each other through significant delays. One side of the galaxy effectively sees ancient versions of the opposite side. Now add Earth's 212 million light-year distance on top of that. Suddenly the entire system becomes layered in time. Ancient light from ancient structure carrying evidence of ancient interaction still unfolding beyond our current view. Astronomy rewards patience because the universe itself moves patiently. Still, despite all the complexity surrounding the interaction, one fact remains wonderfully simple. A smaller neighbouring galaxy stretched a giant spiral across space through gravity alone. No explosions required. No magical cosmic event, just mass, motion, and time. That simplicity is one of the most beautiful aspects of physics. Extremely complicated structures emerge from relatively simple rules, repeated consistently across enormous scales. Gravity pulls, matter responds, time accumulates, galaxies evolve, and eventually systems like NGC 6872 emerge, giant spirals shaped by neighbouring companions into forms so large and strange that they force astronomers to reconsider what spiral galaxies are even capable of becoming. Of course, from Earth, we naturally compare everything to the Milky Way because it is the galaxy we know best. Our home galaxy already feels enormous to human intuition. So the next question becomes almost unavoidable. What exactly would happen if you placed the Milky Way beside NGC 6872 and tried comparing the two directly? Human beings have a habit of treating the Milky Way as normal, which is understandable. It is difficult not to normalize the galaxy you happen to live inside. The Milky Way surrounds every human story ever told, every civilization ever built, every late-night thought, every awkward family dinner, every telescope, every poem, every scientific breakthrough, every species that has ever existed on Earth. Naturally it feels standard, but astronomically speaking, even the Milky Way is already enormous. It contains hundreds of billions of stars. Its disk stretches roughly 100,000 light-years across depending on how its faint outskirts are measured. A supermassive black hole sits at its centre. Spiral arms wind outward through clouds of gas and dust where new stars continue forming. Dark matter surrounds it invisibly in a gigantic halo, extending far beyond visible structure. The Milky Way is not small. Then along comes NGC 6872, and quietly makes our home galaxy look almost compact by comparison. That is part of what makes NGC 6872 so emotionally strange to think about. It forces the brain to rescale something already nearly impossible to comprehend. Imagine standing beside a mountain your entire life believing mountains could not become much larger. Then one day someone casually points toward a continent-sized peak, disappearing beyond the horizon. That is roughly what comparing NGC 6872 to the Milky Way feels like. The first difference is simply diameter. The Milky Way spans around 100,000 light-years across its main disk. NGC 6872 stretches to roughly 522,000 light-years from one elongated arm to the other. 5 times wider, not slightly larger, not somewhat bigger. 5 Milky Ways placed side by side would still only begin approximating the full-stretched width of NGC 6872. And this is where ordinary intuition begins malfunctioning a little, because galaxy size does not increase emotionally the way city size does. A city twice as large still feels understandable. A galaxy 5 times larger than another galaxy already spanning 100,000 light-years becomes difficult to process. The numbers stop behaving normally in the mind, so let us slow it down gently. If the Milky Way were reduced to the size of a standard dinner plate, NGC 6872 would become something closer to a large dining table. Our galaxy would still look impressive sitting there, just no longer dominant, and that comparison matters because the Milky Way itself already contains staggering scale. Light takes over 100,000 years to cross it. The solar system occupies only a tiny corner of one spiral arm. The nearest major galaxy, Andromeda Galaxy, remains over 2 million light-years away. Human civilization occupies less than a blink of galactic time. Now multiply that environment several times over. The second major difference involves shape. The Milky Way is a barred spiral galaxy with relatively balanced spiral structure. Its arms wind outward around a central bar where stars crowd more densely. Though our galaxy contains distortions and tidal streams from past interactions, its overall structure remains comparatively compact and organized. NGC 6872 looks more stretched, more pulled outward. Its enormous tidal arms extend dramatically through space because of gravitational interaction with IC 4970. The Milky Way certainly experiences interactions too. Several dwarf galaxies orbit our own. Ancient mergers left faint stellar streams crossing the galactic halo. And in several billion years the Milky Way and Andromeda will merge entirely. But right now our galaxy remains relatively calm-looking compared to the elongated giant spiral structure of NGC 6872. That difference changes the emotional feeling of the galaxies somehow. The Milky Way feels stable. NGC 6872 feels stretched almost to the edge of stability. Like gravity pulled the galaxy outward and paused just before tearing it apart completely. And yet it survives, still rotating, still forming stars, still maintaining recognizable spiral structure across impossible distances. Another important distinction involves visibility from within. This is slightly frustrating for humanity. We can observe NGC 6872 from outside because it lies far away from us. Telescopes capture its full structure directly. We see the giant spiral shape, the elongated arms, the companion galaxy nearby. But we cannot photograph the Milky Way from outside because we live inside it. Every beautiful image showing our galaxy floating in space is an artistic reconstruction based on astronomical measurements rather than an actual photograph taken externally. Which means, oddly enough, astronomers can sometimes understand distant galaxies structurally more easily than their own. Trying to map the Milky Way from inside is like trying to determine the shape of a forest. while standing among the trees. Meanwhile, NGC 6872 sits far away, helpfully displaying itself from the outside. Distance creates perspective, and perspective reveals another fascinating difference between the galaxies: star formation. Both galaxies still actively produce new stars, but the locations and patterns differ. The Milky Way contains star-forming regions concentrated within spiral arms and molecular clouds scattered throughout the disk. NGC 6872, however, exhibits especially intense star formation along its elongated tidal arms, regions directly shaped by gravitational interaction. The giant spiral almost appears younger in its outer edges because tidal forces triggered fresh stellar birth there. Some of the galaxy's most dramatic-looking regions are also among its most active, and because the arms extend so far, those stellar nurseries occupy distances where many galaxies would already fade into sparse outskirts. The Milky Way, by comparison, feels more contained, more centralized perhaps, again not small, just less extreme. The galaxies also differ in psychological scale. That may sound like an unusual phrase, but astronomy affects human perception emotionally as much as scientifically sometimes. The Milky Way already pushes human imagination close to its limits. Most people never fully internalize what 100,000 light-years truly means. NGC 6872 extends beyond even that stretched intuition. It creates a second layer of scale, a galaxy so large that our already incomprehensible galaxy begins feeling manageable beside it. Astronomy loves doing this. Every time humanity adjusts to one level of enormity, the universe casually reveals another. First, Earth seemed huge. Then the solar system dwarfed Earth. Then the Milky Way dwarfed the solar system. Then giant galaxies like NGC 6872 dwarfed the Milky Way. And beyond galaxies wait clusters, superclusters, cosmic filaments, and the observable universe itself. Perspective keeps expanding outward endlessly. Still, despite their differences, the Milky Way and NGC 6872 share important similarities too. Both are spiral galaxies shaped by gravity and rotation. Both contain dark matter halos extending invisibly far beyond visible stars. Both host multiple generations of stellar populations. Both recycle gas through star formation and supernova explosions. Both likely contain enormous numbers of planets. Both evolve continuously across billions of years. In a sense, NGC 6872 is not alien to the Milky Way. It is an amplified version of familiar galactic processes, a reminder that the same physical laws operate across many scales: gravity shaping stars, gas collapsing into stellar nurseries, dark matter stabilizing rotation, galactic interactions reshaping structure. The same universe repeating similar patterns with different levels of extravagance. And perhaps that familiarity matters emotionally because it connects human existence to larger cosmic systems. The atoms inside every person formed through processes occurring inside galaxies like these. Supernovae forged heavier elements. Galactic evolution recycled them into new stars and planets. The Milky Way and NGC 6872 participate in the same cosmic chemistry. Different scales, same ingredients. Of course, one major advantage the Milky Way offers over NGC 6872 is proximity. Living inside our galaxy allows astronomers to study individual stars in extraordinary detail. We can observe stellar populations, planetary systems, nebulae, black holes, pulsars, and gas clouds directly. NGC 6872 remains too distant for that level of resolution in most cases. From Earth, even powerful telescopes mostly observe the galaxy collectively rather than star by star. This creates an interesting trade-off. The Milky Way provides detail without perspective. NGC 6872 provides perspective without detail. Together they help astronomers understand spiral galaxies more completely. Our home galaxy teaches local structure. The giant spiral teaches large-scale morphology and tidal evolution. One close, one immense, both informative. Another striking difference involves future evolution. The Milky Way's future is relatively dramatic already because the coming merger with Andromeda will eventually transform both galaxies significantly. Computer simulations suggest the collision may create a much larger elliptical or lenticular system billions of years from now. Spiral structure will likely not survive intact forever. NGC 6872 may face similar long-term evolution eventually. Its interaction with IC 4970 already demonstrates how gravitational encounters reshape giant spirals. Additional mergers across cosmic time could alter the galaxy even more dramatically. Nothing in astronomy stays fixed permanently, even galaxies age. That idea can feel oddly comforting late at night. Human beings sometimes imagine permanence where none exists, yet the universe itself remains dynamic at every scale. Stars evolve, galaxies merge, black holes grow, cosmic expansion continues relentlessly. The cosmos changes continuously, and both the Milky Way and NGC 6872 exist only as temporary arrangements of matter and gravity inside much longer histories. Long temporary arrangements, certainly. Billions of years long, but temporary nonetheless. One especially fascinating comparison involves internal communication times. Light requires about 100,000 years to cross the Milky Way. It requires over 500,000 years to cross NGC 6872. That means the giant spiral contains even greater internal separation between regions. Civilizations on opposite sides, if any exist, would effectively live in different historical eras relative to each other's observations. Even within a single galaxy, time delays become enormous. The larger the galaxy, the stranger now becomes. And perhaps that is one of the deepest differences between these systems psychologically. The Milky Way still feels barely graspable to human imagination. NGC 6872 crosses into territory where ordinary concepts begin dissolving. Distances stop feeling real. Timescales stop behaving intuitively. Galactic structure becomes almost geological in emotional texture, something vast, slow, layered, and ancient beyond ordinary experience. Yet despite all its extraordinary size, NGC 6872 remains only one galaxy among countless others spread through the observable universe, a giant certainly, but still part of something larger. One of the most interesting things about NGC 6872 is that it may not actually represent the limit of how large spiral galaxies can become. It only represents the limit we have clearly found so far. Astronomy has a long history of discovering something enormous, declaring it exceptional, and then eventually finding something even stranger hiding farther away in the dark. The universe rarely rewards confidence in upper limits. For a while, people assumed the Milky Way was probably fairly typical. Then astronomers found giant ellipticals far larger. Then they found galaxy clusters, then superclusters, then enormous cosmic filaments stretching across hundreds of millions of light years. Scale keeps expanding outward. So when scientists study NGC 6872 carefully, they are not simply studying one impressive galaxy. They are studying a clue about galactic evolution itself, a clue suggesting that under the right conditions, spiral systems can survive, stretch, and continue growing much farther than once expected. And that naturally raises another question. If galaxies like this exist today, what kinds of galaxies existed earlier in cosmic history when the universe was younger, denser, and far more chaotic? Because the early universe was a very different place. Galaxies lived closer together then. Space itself had expanded less. Matter was packed into smaller volumes. Interactions and mergers happened more frequently. Giant clouds of gas flowed into forming galaxies continuously. Everything was busier. Modern galaxies often feel mature, organized, settled into long-term evolutionary paths. But early galaxies resembled construction zones. Stars formed rapidly, black holes grew aggressively, galaxies collided and merged constantly, while large-scale cosmic structure assembled itself over billions of years. Astronomers sometimes describe this era as cosmic noon, which sounds unexpectedly peaceful considering galaxies were crashing into each other everywhere. Still, the phrase captures something important. The universe experienced periods of especially intense galactic activity. And because interactions were more common, some astronomers suspect enormous galaxies may have formed unusually quickly during those ancient epochs. In fact, modern telescopes already hint at galaxies in the early universe that appear surprisingly massive far earlier than older models predicted. This became especially interesting after observations from the James Webb Space Telescope began revealing galaxies existing only a few 100 million years after the Big Bang that seemed unexpectedly bright and mature. Some appeared larger and more evolved than scientists anticipated for such early cosmic times, which immediately caused astronomers to do what astronomers do best: stare at data quietly while reconsidering several assumptions simultaneously. The early universe may have built structure faster than expected, and if that is true, giant galaxies like NGC 6872 become especially valuable because they help scientists understand the mechanisms allowing large-scale galactic growth. How much interaction can a spiral survive? How rapidly can galaxies accumulate mass? What role does dark matter play in stabilizing huge structures? How long can star formation continue across giant disks? These questions are not only about one galaxy, they're about cosmic history itself. One possibility astronomers consider is that some early galaxies may actually have been more extended, gas-rich and dynamically active than many modern spirals. Young galaxies in the ancient universe often contained huge amounts of cold, gas-feeding rapid star formation. Gas changes everything. A galaxy rich in gas behaves differently from an older system dominated mostly by aging stars. Gas clouds collapse into stellar nurseries. Spiral patterns strengthen through density waves. Interactions trigger massive bursts of star formation. Early galaxies may have resembled enormous turbulent star factories, and because the universe was denser overall, interactions between galaxies happened constantly. Small proto-galaxies merged into larger systems repeatedly. Dark matter halos gathered matter efficiently. Black holes at galactic centers grew rapidly as material streamed inward. The cosmos was building itself. NGC 6872 may represent a surviving example of processes that were once far more common. A giant spiral still visibly shaped by gravitational interaction. A galaxy preserving clues about how large disks evolve under tidal stress. A structure balanced between order and disruption, which becomes even more fascinating when you remember that the galaxy itself already appears ancient from Earth's perspective. We see NGC 6872 as it existed over 200 million years ago because of the time its light required to reach us. That is relatively recent cosmically speaking, but still unimaginably old by human standards. Dinosaurs vanished around 66 million years ago. When the light currently reaching Earth left NGC 6872, mammals had only recently begun spreading widely across the planet. Human beings would not appear for another vast stretch of time afterward. Yet even then, the galaxy already looked mature and enormous. Galactic evolution unfolds across intervals so long that even giant structures can appear stable for hundreds of millions of years while continuing to change underneath, and the future of galaxies may become quieter overall. That is one of the strange large-scale trends astronomers observe. The universe appears to be gradually calming down. Not everywhere at once, of course. Individual galaxies still form stars, black holes still feed, interactions still occur. But compared with earlier cosmic history, star formation rates overall have declined. The universe was once much brighter in terms of stellar birth activity. Billions of years ago, galaxies converted gas into stars far more aggressively than most do today. Astronomers call this decline cosmic star formation history, which sounds suspiciously like the universe slowly becoming tired. In reality, galaxies are gradually consuming or losing the gas needed to create new stars. Some systems continue acquiring fresh material through mergers or inflows. Others slowly exhaust accessible reservoirs over time. Eventually, many galaxies become quieter, redder, older, dominated by long-lived low-mass stars. In the distant future, the cosmos may contain far fewer bright blue star-forming galaxies than it does today, and giant spirals like NGC 6872 may eventually become increasingly rare. That possibility gives the galaxy a slightly bittersweet quality scientifically. We may be observing a kind of evolutionary phase less common in the future universe, a giant active spiral stretched dramatically by interaction, yet still alive with star formation. Not fully settled, not fully disrupted, still dynamic. Of course, future universe in astronomy usually means absurdly distant timescales, billions upon billions of years. Human civilization occupies such a tiny slice of cosmic history that the rise and fall of galactic populations happens almost entirely outside ordinary comprehension. Still, the long-term future of galaxies becomes remarkably interesting once you begin thinking beyond current cosmic eras. Take the Milky Way, for example. Several billion years from now, the Milky Way and Andromeda Galaxy will likely merge into a much larger system. Spiral structure may disappear. Star formation could eventually slow as gas supplies change. The resulting galaxy may resemble a giant elliptical or lenticular system, more than the elegant spiral skies we know today. In a sense, galaxies age out of spiral structure eventually. Not always immediately, not always completely, but repeated interactions tend to randomize stellar orbits and disrupt organized disks over time. NGC 6872 itself may someday experience similar transformation. Its elongated arms already reveal tidal stress. Additional mergers in the far future could reshape the system dramatically. Star formation may eventually decline, spiral patterns may fade, even giant galaxies are temporary arrangements. Long temporary arrangements, certainly, but temporary. This idea changes how astronomers think about galactic beauty too. Spiral galaxies are not eternal cosmic artworks hanging motionless in space forever. They are evolving systems caught during specific phases of history. The Milky Way exists during one stage. NGC 6872 exists during another. Future galaxies may look entirely different. And the early universe almost certainly contained galactic structures stranger and more chaotic than many existing today. The more telescopes improve, the clearer this becomes. Astronomers increasingly discover galaxies that challenge neat expectations. Giant galaxies appear in surprisingly early. Compact galaxies containing enormous stellar masses. Systems undergoing intense bursts of star formation. Galaxies interacting through huge tidal structures. The universe does not evolve smoothly and politely. It experiments constantly. NGC 6872 embodies that experimental quality beautifully because it pushes spiral structure almost beyond what feels reasonable. Its enormous tidal arms stretch so far that they seem nearly detached in places. Yet star formation continues there. Rotation continues there. Gravitational coherence survives there. The galaxy almost feels like a question posed by nature itself. How far can a spiral go before becoming something else? And astronomy still does not fully know the answer. There may be larger spiral galaxies waiting undiscovered farther away. Some may remain too faint or distant for current telescopes to observe clearly. Others may have existed in earlier cosmic eras before evolving into different forms. The observable universe contains hundreds of billions of galaxies, perhaps more. Humanity has studied only a tiny fraction carefully. That thought alone is wonderfully calming somehow. No matter how much science learns, there will still be more sky remaining afterward. More galaxies, more structures, more mysteries. And perhaps that is why giant galaxies affect people emotionally as much as intellectually sometimes. They force the mind into scales large enough that ordinary worries temporarily loosen their grip. A galaxy spanning over 500,000 light-years places things differently in perspective. Deadlines shrink, arguments shrink, embarrassing memories from 7 years ago shrink considerably. The universe is not trying to make human life feel unimportant exactly. If anything, astronomy often does the opposite. It reveals how extraordinary consciousness actually is. Tiny biological creatures evolving on one small planet somehow learned enough physics to understand giant galaxies hundreds of millions of light-years away. That is astonishing. The universe became aware of itself at least in one place, and through telescopes and mathematics, it learned to study structures larger than the imagination comfortably handles. NGC 6872 becomes part of that story too. A giant spiral galaxy stretching across space, while human beings on Earth analyze ancient photons arriving from its distant past. There is something deeply beautiful about that exchange. Light travels for over 200 million years. A telescope captures it, a conscious mind interprets it, and suddenly a galaxy unimaginably far away becomes something we can think about quietly before sleep. Perhaps that is one reason astronomy feels strangely intimate despite the scales involved. Distance does not prevent connection. We are physically tiny compared with galaxies, yes, but understanding creates its own kind of closeness, and understanding NGC 6872 ultimately reveals something larger than one galaxy alone. It reveals that the universe is dynamic, evolving, layered with history, and still far stranger than human beings fully expected even after centuries of scientific discovery. The giant spiral is not an exception to cosmic evolution. It is evidence of it. A structure shaped by gravity, dark matter, star formation, galactic interaction, and time across billions of years. A reminder that galaxies themselves are living histories written across deep space. And when we finally step back from all the measurements, all the comparisons, all the tidal interactions and dark matter halos, what remains is something simpler. A giant turning slowly through darkness, carrying billions of stars across 500,000 light-years, while the universe continues expanding quietly around it. By the time you finish thinking about NGC 6872, something slightly strange tends to happen to your sense of scale. The mind begins the journey normally enough. You hear the words, largest spiral galaxy, and perhaps you imagine something only moderately bigger than the Milky Way. Then the numbers arrive, 500,000 light-years wide, hundreds of billions of stars, spiral arms stretched across impossible distances by gravitational interaction. Light itself needing more than 522,000 years just to cross from one side to the other, and slowly, almost without noticing, your ordinary sense of proportion starts slipping quietly out of its usual shape. Because galaxies like NGC 6872 are too large to fit comfortably inside normal human intuition. You cannot truly picture 500,000 light-years, not emotionally. You can repeat the number, you can understand the mathematics, but somewhere beyond a certain scale, the brain stops converting measurements into lived experience and instead settles into something softer. Wonder perhaps, or humility, or maybe just silence. Astronomy often creates that effect. The universe becomes so enormous that eventually the mind stops trying to dominate it and simply sits beside it for a while instead. And there is something peaceful about that. NGC 6872 has existed for billions of years already. Before Earth formed, stars inside that galaxy were already orbiting, quietly through darkness. Before dinosaurs appeared, its spiral arms already stretched across intergalactic space. Entire species rose and vanished on our planet while gravity continued shaping the giants slowly, patiently, without urgency. Galaxies do not hurry. That may be one of the most comforting things about them. Human life often feels rushed. Clocks everywhere, notifications, deadlines. Tiny glowing numbers reminding us that another hour disappeared somehow while we were trying to remember why we walked into a room in the first place. The universe operates differently. A spiral arm can take hundreds of millions of years to evolve. A galaxy collision unfolds across intervals longer than complex life has existed on Earth. Stars burn for billions or even trillions of years. And somewhere inside NGC 6872 tonight, light continues travelling between stars that will never know humanity existed at all. That thought sounds lonely initially, perhaps, but I do not think it really is. If anything, astronomy often reveals how connected everything actually becomes through time and physics. The atoms inside your body were forged inside ancient stars long before the solar system formed. The oxygen you breathe came from stellar fusion. The calcium in your bones came from exploding stars. The iron in your blood emerged through processes occurring inside galaxies over cosmic history. You're not separate from the universe observing it. You're one tiny temporary arrangement of it. And somehow, improbably, that arrangement became capable of understanding galaxies. That still feels miraculous to me, honestly. A species evolving on one small rocky planet around one ordinary yellow star learned enough mathematics and physics to measure structures hundreds of millions of light years away. Human beings discovered that galaxies rotate, collide, stretch, form stars, contain dark matter halos, and evolve across billions of years. Tiny conscious creatures on Earth learned how to read ancient light. That is extraordinary, no matter how many times science does it. Of course, astronomy also has a way of making human worries shrink slightly, not disappear entirely. Life remains real. Bills still exist. Sleep schedules still collapse mysteriously after midnight. Somebody somewhere is currently searching the entire house for an object already in their hand. But giant galaxies provide perspective. Compared to NGC 6872, most daily anxieties become wonderfully temporary, not meaningless, just smaller. And perhaps smaller is exactly what many thoughts need sometimes. The universe does not erase human life by being large. If anything, its scale makes consciousness feel more precious. Across all the darkness and distance, here we are, little thinking creatures capable of asking questions about galaxies we will never visit. That ability alone feels astonishing, especially when you consider how fragile it all really is. The Earth is tiny compared with galaxies. Human civilization is young compared with cosmic time. Our species occupies only a brief moment in universal history. And yet, during that brief moment, we built telescopes capable of detecting light from NGC 6872 after a journey lasting over 200 million years. A photon leaves a distant galaxy, while dinosaurs are long gone, but humans do not yet exist. It crosses intergalactic space for unimaginable ages. Eventually Earth forms civilizations. Languages evolve. Mathematics develops. Telescopes appear. One night, that photon enters a detector built by curious primates on a small world orbiting an ordinary star, and suddenly a distant galaxy becomes known. The universe is filled with journeys like that, light carrying stories across darkness endlessly. Some photons reaching Earth tonight began travelling before mountains on our planet looked the way they do now. Some left their galaxies before mammals dominated Earth. Some started moving toward us before the solar system existed at all. Astronomy turns the night sky into history visible in real time, and NGC 6872 is part of that immense archive, a giant spiral galaxy still drifting through space, while its ancient light quietly reaches telescopes on Earth. Perhaps the strangest thing is that the galaxy itself already changed beyond the version we see now. The light reaching us tonight left over 200 million years ago. Since then, stars moved, gas clouds shifted, new stars formed, others exploded. The interaction with IC 4970 continued evolving. The real present-day galaxy remains hidden from us behind time itself. We never observe the universe exactly as it is. only as it was. That idea can feel melancholy at first, but there is also something beautiful about it. The cosmos allows information to travel, even if slowly. Light persists. Across impossible distances, photons continue faithfully onward, carrying traces of distant events until eventually something notices them. Sometimes that something is a telescope. Sometimes it is you. And maybe that is enough. One of the reasons giant spiral galaxies feel calming late at night is because they exist entirely outside ordinary human urgency. NGC 6872 does not care whether anyone understands it completely. It does not rush toward conclusions, it simply continues rotating through darkness while gravity and time shape it gradually. There is wisdom in that pace perhaps, or at least relief. Modern life often encourages the feeling that everything must happen immediately. Instant responses, instant information, instant progress. But the universe itself builds its most extraordinary structures slowly. Stars require time, galaxies require time, even light requires time. Nothing truly large happens quickly, and the quietness of space matters too. People often imagine the cosmos as dramatic and loud because films taught us to expect explosions constantly echoing through the stars. Real space is mostly silent, vast, dark, patient. Galaxies drift through enormous emptiness where distances become difficult to emotionally survive without imagination. NGC 6872 itself exists inside that silence. A giant spiral stretched across 500,000 light-years, surrounded by darkness so deep that even neighbouring galaxies remain separated by immense voids. Yet despite all that emptiness, the universe continuously creates structure. Gravity gathers matter, stars ignite, galaxies rotate, black holes grow, chemistry becomes biology, consciousness appears. Somehow the cosmos keeps building complexity inside silence. That may be the most hopeful thing astronomy reveals. The universe is not merely empty space with occasional stars scattered randomly. It is creative, dynamic, continuously evolving into richer forms over time, and giant galaxies like NGC 6872 represent one expression of that creativity, not designed, not planned. Simply emerging naturally from gravity, motion, matter, and billions of years. A spiral so large it almost feels impossible, and yet there it is. Still turning, still forming stars, still stretching across darkness while invisible dark matter halos hold the structure together. Still carrying billions of suns through intergalactic night. If you stepped outside tonight under a clear sky, you would not see NGC 6872 with your eyes alone. The galaxy is too distant, too faint. Above you, the stars visible from Earth belong mostly to our own galaxy. But somewhere beyond them, far beyond the Milky Way, beyond local galactic neighbours, beyond distances ordinary thought comfortably handles, the giant spiral continues existing whether anyone looks at it or not. That is another strangely comforting truth. The universe does not depend on observation to remain beautiful. Galaxies rotated for billions of years before human beings evolved. Stars exploded long before life appeared on Earth. Cosmic structures formed in darkness before any conscious creature existed to notice them. Reality exceeds awareness. And yet, awareness appeared anyway. Somewhere in all this enormous silence, matter arranged itself carefully enough to become curious. Perhaps that is the real miracle. Not merely that giant galaxies exist, but that tiny beings inside one ordinary galaxy learned how to find them. And now, after spending this time drifting mentally through stretched spiral arms, ancient light, tidal interactions, dark matter halos, and star-filled distances larger than human intuition can comfortably hold, perhaps the universe feels a little quieter than it did before, or maybe simply wider. Either way, somewhere tonight, NGC 6872 continues its slow, enormous rotation through deep space while light leaves its stars and begins another impossibly long journey outward into the dark.